Labrīt, hello. Hello, nice to see people joining us. So I will start in a few minutes, so you'll wait a bit. Okay, I think it's time to start our second day session. So welcome to MarTe Sales Technical Workshop regarding physical modeling and blue and green transitions in Baltic Sea and beyond. Today, our focus will be on industry insights and some practical results from physical modeling and how we can do some kind of product and how we can use this. And our first speaker in this morning, Laura Agapova, Latvia's flotte. Is it correct? No. LVR flotte. With her talk, maritime innovation examples from LVR flotte, fleet modernization and collaboration models. So I give floor to Laura. Yes, so come here and
thank you.
Yes, so you can start, yes.
Okay, good morning those who are present and those who are watching us from a distance. My name is Laura Apoga. I am Development and Communications Project Manager at LVR Flotte. And I wanted to thank you for inviting us to this workshop and for inviting us to the project, MarTe. We have joined very recently, only in December, in the status of interested stakeholder, which we definitely are, as we support maritime innovations and maritime technology, maritime technology excellence, since as a technical service provider, we are dependent on maritime technology on daily basis. I will be honest to say that I myself, I do not have any competency in deep tech tools or physical modeling. But what I am is fond of connecting different fields, different disciplines, as learning the unknown widens our perspective. And I hope that you will find interesting our take on maritime innovation from the point of view of service provider who works in the port daily. So I will speak about our fleet modernization and our development project. So, but before that, I will briefly introduce you to our company. So we are a technical service provider for ports. We are a subsidiary company of the Port of Riga Authority. We were established to carry out these technical functions related to ports infrastructure management. So a lot of times our work is invisible, but without it, port cannot operate in a safe manner and be open to navigation all year round. So realizing this responsibility upon us, our mission is thus to provide high quality service, so thereby contributing to the competitiveness of the Port of Riga and also to other ports in Latvia as well. We work both onshore and in the waterways of the port with 8 service lines in our portfolio. So hydrographic surveys, that's a full set of services starting from the data collection, analysis, processing, and creating final measurement plans tailored to clients' needs. Icebreaking, this is a strategic function, and actually this is a historic moment. As I left to Ventspils yesterday, our icebreaker Varma went into service in the Gulf of Riga. So yes, this is a matter of navigation safety, and we're very proud of Varma's work. Maintenance of aids to navigation, another core competency of ours. We service floating and shore-based aids to navigation, and also provide monitoring for navigation aids. Pilot transfer, our job is to make sure that pilots reach vessels and then get back safely to the pilot base station. This service is offered 24/7. Oil spills response from preventive measures to operational response. And while our vessels are not used for our functions, we offer charter opportunities for long or short term. On the land side, we provide infrastructure management. This might appear as a single item in this list, but actually it's a comprehensive set of services, and it requires coordination among different divisions. So we take care of the railroad network, of roads, territories, snow clearance, waste management, security systems. So it's a comprehensive set of services. All of these services we provide at the port of Riga, but as I mentioned in the mission statement, that we work in other ports of Latvia as well. So with only 4 of our services: hydrography, vessel charter, maintenance of aids to navigation, and to a certain extent also oil spills response. Now we provide we deliver our services with our fleet, which consists of technical fleet and fleet of vessels. Those are our main assets. It's a small but capable and efficient fleet enough to service our ports. We work with an icebreaker, multifunctional vessels, pilot boats, hydrographic vessel, and drone, USV Otter. And if we speak about technical solutions, I wanted to bring your attention to drone Otter, and I will speak about it more in a minute as well. But this drone has completely changed the approach how we deliver hydrographic surveys. It has increased our mobility to reach also those places that were previously inaccessible. So you see on this map, this is our operational area. In inland waters, we deliver hydrographic surveys, and we have been with that as well in Nasva and Klaipėda. Along the shoreline, we provide mostly maintenance of aids to navigation, monitoring of aids to navigation, and also engage in vessel charter deals with other ports. Taking into consideration our operational area and our professional expertise, in long term, this is how we see ourselves, that our role would be this platform through which technical resources and technical competencies among ports could be exchanged. So we promote a closer collaboration of ports in the technical sense, as that is the matter of resource efficiency. But now about our development projects and maritime innovation. So innovation is one of the pillars of our strategy, and we always try to find a way on how to become more efficient. And in the areas where we can not innovate ourselves, we give this opportunity to others to test their ideas or products in the real maritime environment. The only principle is that those projects which we undertake or in which we collaborate with, they must bring value to either our resource efficiency or would be beneficial to the Latvian port system. So first that I want to mention is the most important project of 2025 of last year. We have introduced, we completed a major fleet modernization project with the support from EU military mobility funds. And we have acquired a new multifunctional ice class vessel with dual use capabilities. This vessel strengthens our operational capacity in the range of the services that we already provide. And also it expands the tasks that we can perform. The vessel is built on shoalbuster design, and it is suited to variety of tasks in various maritime environments, which supports our strategy. Currently, Laura is involved in ice management. So since she has ice class, she does ice breaking. And as a matter of fact, today Laura is in Ventspils, not for the ice breaking, but for helping out our colleagues in Ventspils with aids to navigation. They must be lifted out during the winter conditions. So you might see Laura today if you're at the port. During the technical planning, we consulted closely with our clients, with stakeholders, and also with partners in defense sector to ensure that the ship would meet the needs of our partners at ports and at the military sector. So the result is this, and a bit about the technicalities. So the vessel has a spacious deck. This was requirement from the defense partners, as this vessel in the military aspect could serve as a supply vessel for military needs. But also it is important for us, since we now are able to place 4 buoys on the deck. The vessel has equipment suitable for transferring heavy objects. It has waterfall winch, hydraulic deck crane with a capacity of 12 tons outside the vessel, but 19 on the deck area. A-frame that supports that is meant for leveling works, tugger winch, also universal bracket for research equipment, also if necessary. And yes, an equipment for emergency assistance, latest navigation programs. So this vessel can also serve as a platform for further innovation. Another thing, this is our first hybrid propulsion vessel. It is able to run on battery power for, officially it says 1, but we have tested in up to 2 hours. And of course, this is an important step toward to reaching environmental goals. But for us as well, it means the resource efficiency. Now, when we there were various aspects that we considered when choosing the batteries. So one of the things is that we chose batteries because they can be charged using the existing infrastructure, so you don't have to build something anew. It was important for us to keep the vessel dimensions unchanged, but the batteries take space. So this is the amount of space that we could devote for battery room. But when thinking also about our further fleet modernization, for example, in the plans of modernizing our pilot boats, these are the conditions that we consider. There are quite a few alternative fuel possibilities, but we must ensure high speed. We must ensure the ability to work in ice conditions. We must take into consideration resource availability and many other aspects. So, and if you have something to add about this, then I welcome the discussion afterwards. So yes. Now, Laura, she supports all of our services, as I mentioned, especially the icebreaking operations. But with this vessel, we can also develop new service lines. For example, leveling works or support for dredging projects. The vessel is fit for transfer of personnel and equipment, as I mentioned, in the supply, as a supply vessel for military needs, emergency technical assistance. And actually, this was the first task of vessel Laura. She helped another vessel in distress. And also, the direction in which we look at is offshore infrastructure servicing, wind farm servicing. And this is not actually, we had an example just in December. We collaborated with EOLOS as their subcontractor for installing of two smart buoys in the Elvin project. So Elvin project has chosen two sites in Latvian and Estonian waters. And so before starting the project, they must do their research. So I'm not really into smart buoys. I cannot comment on that matter, but our job was to make sure that these smart buoys are placed in their right locations. And since we have the technical capability and also a team, experienced team, navigation team, so we managed this project, and now these smart buoys are located in their rightful places. And we assured ourselves that we can participate in projects like these. And so since we will speak about wind later today, I also wanted to let you know that such technical support is available in Latvia. Now, back to Otter. Our drone Otter that I mentioned before, these are not new news. Otter has been in our fleet since 2022. It was the first of this type of drone in the Baltic states. We have worked already for 4 years with Otter, but it is not about introducing some trendy technology in the fleet, but it's a matter of efficiency again. So efficiency is the main principle in any project that we undertake. And yes, now we are able to offer this service also to the clients that previously could not even have this service, as it would be very difficult to reach inland waters with our vessels. So now we do not plan to retire our hydrographic vessels, not at all, but this just adds a multimodality aspect. We continue our work with hydrographic vessel in the port of Riga for regular measurements. And we service other clients in Latvia with the drone. So that is more attractive to the client, as that reduces costs, as you can see. Yes, that has really increased our client base. There are advantages to each type of vessel. Of course, you can use drone, it's convenient, but in the meantime, when the weather conditions aren't that good, then we can employ a vessel. So to continue on, we collaborate also with R&D community. We participate in research projects. For example, this project that I really like is the collaboration with a local scientist who came up with the idea on how to reduce emissions from diesel engines. As a fleet operator, we understand that not all of the fleets can switch to alternative fuels or do retrofitting. It is a matter of course, of the finance, or for example, what to do with those vessels who must operate in ice conditions. So we found that this could be an interesting. This could be an interesting project, and so during this project, a prototype plant and technology was developed and tested on board our vessel, Liva. Of course, it is not supposed to be on a vessel Liva, as Liva does not produce that much gas emissions.
Ko viņi tikko gādāja? Mums jau sezona sākās, kāpēc?
Someone else's.
Vakar sanāca saruna ar Līgu telefonu.
Inga Kalniņa, could you please
Jā, nu,
switch your microphone?
Overpress atsūtīja rēķinu par papildu darbiem.
Inga Kalniņa, could you please switch your microphone?
1790, tas ir autoru uzraudzība, 2 dienas, viņi sauc autoru uzraudzību. Es jau Līgai vairāk kārtīgi teicu, tas ir tas, ko viņi stāsta mūsu sarunās par papildu darbu, ir papildu samaksa. Ja viņiem nebija jātaisa maketi, viņi neierēķināja sākotnējā. Tā mēs šobrīd viņiem prasām taisīt maketus, attiecīgi viņi ierēķina.
Tu izslēdz mikrofonu.
Aizrunā.
Fine, thank you. So sorry for interruption. We can continue.
Yes, thank you. No problem. This happens. That is very common. So back to the project with on Liva. So this technology is not supposed to be on a vessel Liva. There are types of vessels that have shown interest already about this technology. I think Stena ferries, and also it can be used for plants on the ground for the emissions as well. We will continue collaboration with this project, and we are currently looking for funding programs for the next phase of this project. So it could be an alternative to scrubber systems. Of course, our long-term partner has been, Of course, our long-term partner has been as well Latvian Institute of Aquatic Ecology. So we also provide this technical support for their research activities at the sea. This is very new. Just a few days ago or last week, a pilot project was approved for funding. So in this project, we collaborate with Baltic partners in the topic of decarbonization of pilot boat fleet. The leading partner is Tallinn University of Technology. I don't know if anyone from Tallinn is present, but we are excited to begin this project. So each partner will have will develop their idea on how to decarbonize their pilot boats fleet. Our idea is to develop an integrated monitoring system, so that we could, through that monitoring system, also optimize our engine performance, improve maintenance strategies, encourage fuel efficient navigation practices, as a lot of times this depends on the human factor. We collaborate also across industries, our partner LMT, with our partner LMT. So we are two completely different companies, but we have an innovation open mindset, and we both recognize the 5G potential in maritime industry. Connectivity for us is important, not just because 5G is something trendy, but because when we provide hydrographic measurements that produce so large volumes of data, and 5G allows for faster data exchange. So this could improve our service provision. Also, the same applies to dredging projects. Those also produce large volumes of data. So we explore different options how to make that data transfer from the ship to the shore faster and in real time. So we have been part of many 5G initiatives. Also, very recently, we participated in the demonstration day during the technology forum, and together with our partners from LMT, Submerged Baltic, Bayron, Riga Technical University, Spark Technologies, Each partner demonstrated their own digital solutions, or for example, their products. So from drones to edge computing solutions and autonomous drone deployments. So Vessel Laura served as a mothership for the drones. In the innovation projects, it is very important to have strong partners by your side. So during all of our work, we have built this innovation ecosystem around us. Now, this is not an exhaustive list of all our partners, there are only a few of them, but it is important, and that's the key into developing sustainable solutions, because there are many great ideas that are left on the shelf as a prototypes and do not see actually the market. And in order to get past that, you must have your community that supports and validates your ideas so that they can be introduced in the industry. And our collaborative approach also extends across borders. Last summer, we concluded a memorandum of understanding between Latvian and German partners to promote cooperation in digital innovation in maritime technology. So this partnership brings together both ports, Port of Hamburg, Port of Riga, both fleets, ourselves and Flotte Hamburg. We make friends with other fleets abroad as well. The objective of this memorandum of understanding is to work together to find practical digital solutions on the challenges that both ports face. For example, us, together with Flotte Hamburg, we work on solutions for large-scale data exchange, as I mentioned in the example with the large volumes of data produced in hydrographic measurements, and also solutions for monitoring system of the technical condition of ships for predictive maintenance. So that was a brief overview of what our company does, and I hope that gave you a worthwhile insight or a perspective of someone who works at the port daily. And the message that I want to leave you with is that we provide technical services for safe and efficient use of the port infrastructure. We focus on innovation and partnership. And if this overview has sparked any questions, I welcome the discussion. So please come and talk to me. I welcome the conversation. Now, I thank you for your attention and wish you a fruitful day. Thank you.
Some questions as well, colleagues, maybe colleagues online. If you brave enough, that just we have a couple minutes for questions though. Again, so thank you for coming. So Tuesday we have two Lauras from Riga, resting in Ventspils.
Lauras are in Ventspils, yes.
Yeah, so it's nice to see, and it's very interesting because I think you have no contacts with Ventspils University, and probably it's a good time to establish also some kind of research and developments together with Ventspils. And I think we can think about and discuss it a bit later. Yeah, so no questions. Oh, wait a second. I would like to issue you
a diploma.
Diploma.
A first diploma from Ventspils University.
Yes.
Thank you so much.
Check for your phone. Yes. Thanks again, Laura, and we are going to our next speaker. And so, Jēkabs Pieditis, please come here. University of Latvia, and his talk, Wind Solar Powered Energy Systems for Autonomous Coastal and Offshore Infrastructure. Actually, Laura, your talk was very beautiful start of the day, because the next talks are somehow related to your mentioned activities, and we try to think out how developments could be connected with Baltic Sea and using your fleets to use services what you provided together with new technologies as well. So Jacobs, please come and try to find the presentation. Yes, should be fine.
So much.
Yeah.
Good morning, everyone. It's a pleasure and an honor to be here today. So quick introduction about myself. I am Jacobs Priedītis, a bachelor's level student of physics at the University of Latvia. I also work as a physics teacher at the Rīgas Natālijas Daudziņas Vidusskola, and I'm also an aspiring researcher working at the Numerical Modeling Institute of University of Latvia. And what I'd like to share with you all today is the research that I've done at the Institute with my colleagues for the past year or so. Mostly all of us still undergrad students. We've been working on assessing the potential for autonomous infrastructure. Infrastructure that works purely on the basis of wind power and solar power with the assistance of battery storage. We're focusing mostly on communication towers in particular, though any infrastructure, these principles would apply to any sort of infrastructure. So given this topic's connection and relevance to this seminar, I hope that some of our findings are of some value, or at least spark some thoughts. So without further ado, quickly the sort of structure of this presentation. I'd firstly like to speak on the objectives of this project, then the importance for coastal and offshore applications, then most importantly, the results, and finish off with conclusions in further areas of research, the plans for the future. So the primary aims of this project are as follows. Firstly, during the first stages of the project, the initial goal was assessing whether such infrastructure is even feasible in the first place. If it was found to be either technically too impractical or too expensive or too unreliable, then I would probably not be here today. So assessing the potential and the feasibility was the first important goal. After that, the next was mapping the potential of such infrastructure across all of Latvia, and in later stages across all of Baltics, in order to find the most suitable places for the development of such infrastructure. Because even with such a relatively small area as the Baltics are, the differences can be quite significant, not just comparing the coastal and offshore regions to the inland ones, but also within these categories. This is also a time to admit that most of the research was primarily done for inland applications at first, as the prototype for the power is located inland. However, for the purposes of this presentation, I'll try as much as possible to bring an offshore and coastal perspective to all of this. So once we had a clear indication that all of these towers are feasible, the next step was to look at ways to optimize them. So if we want the system to be as effective as possible, then we would have to look at, for example, what kind of combination of solar, wind, and battery would give the most efficient and the most cost-effective outcome. What the differences for this most optimal system would be across various places in the Baltics. How large should the battery bank be, and just a flurry of similar questions that have to be answered in terms of optimization. Another important part of the project was identifying the shortcomings, the various periods of outages, when they occur, how long they are, how severe they can be, and even if the outages are relatively rare, then understanding the exact conditions under which these outages happen is crucial for improving the systems, and also showing what kinds of applications it can support, which leads to my next aim, determining what power usage profiles could such systems be useful for, and hence what applications could sensibly be run on them. Of course, we're talking about relatively low to medium power infrastructure. We're not talking about off-grid factories or data centers or anything like that. Mostly medium power infrastructure, such as communication towers, monitoring equipment, certain categories of measurement devices and similar distributed systems for which such a setup could be practical. And finally, it's also worth mentioning that this is not merely a hypothetical project, not something that is merely from the passion of some students. All the calculations, the modeling, and the configurations have actually been used to build a functioning tower in real life, which means that all of this analysis has also practical grounding, not just theoretical. And although the tower is set to run, have the wind turbine spinning and the solar panels working only within the next month or so, it has been built in real life so far. So moving on, for the importance in particular for the offshore and coastal applications. These regions, I'm sure all of you know better than I do, come with their own sets of difficulties. Infrastructure in these regions is quite sparse. Grid access can be limited or non-existent, and weather conditions are harsh enough that any system of this sort not only has to be self-sufficient in terms of energy, but also be physically robust. And the further from land you go, the more difficult everything becomes. There's also the less pleasant, but unfortunately unavoidable factor that, given the current political landscape being as turbulent as it is, the importance of a two-layer safety net is more important than ever. And unfortunately, this is no longer some theoretical, hypothetical doomsday scenario, but rather this deliberate interference, jamming, GPS spoofing, and other forms of electronic interference are real risks. And the Baltic Sea in particular has seen plenty of such activity, which highlights the increased need for such infrastructure. So the results section, I'll organize it by starting off talking about the inland point, the one that we have already built, then move on to a more broad perspective across all of Latvia, and then focus on a coastal point. So this inland point is located in the central southern part of Latvia near the city of Dobele. For a very important piece of context about the further slides and calculations that are done, this current tower configuration contains a 5 kilowatt turbine at a height of 56 meters, solar panels with a total power of 18 kilowatts, and batteries at a total capacity of 25.6 kilowatt hours, which of course doesn't mean much if we don't know the power consumption. The most important part to scale it against is the power consumption, which we found that of these sorts of communication towers, we used an analogous one in a similar location. We found the average to be 2.1 kilowatts, slightly more during winter and slightly less during the summer. And using 30-year data from the New European Wind Atlas, as well as ERA 5, and simulating a battery which every hour takes a certain amount of energy from the solar powers and turbines, and uses up a certain amount of energy from this power consumption. We modeled the way that this tower works. So finally getting into the real results, one of the beautiful things about a hybrid energy system is the fact that during the months in which the solar power generation is relatively lower, the winter months, the wind power is slightly higher, which helps significantly to ensure the autonomy of such infrastructure year-round. It is important to mention that during the winter months, the generation is still lower. The wind during these months is not as high as the solar power during the summer, though especially with us placing the solar panels at an angle which is most efficient, in particular for the winter months at a 60-degree angle. The situation is made to be slightly better for autonomy in the winter months as well. When modeling the outage percentages for this current configuration in this inland point of the tower, we found that the average across the entire year would be roughly 6%, essentially non-existent during the summer months. However, the real problematic areas would be the winter months, in which it ranges anywhere from 15 to 18 to 19% during these months. Which is, of course, not the most ideal outage percentage. And this is something that would certainly have to be improved, and therefore we also ran an optimization algorithm to find the most ideal, the most cost, and therefore we also ran a 99% uptime for this inland point. And we found that for this power consumption profile of an average of 2.1 kilowatts, ideally, most efficiently, we would use solar power of roughly 37 kilowatts. Wind power would not change so much. A 6 kilowatt turbine would do the job, and a battery capacity of 54 kilowatt hours would be sufficient. And when it comes to cost, we also calculated the cost using the current energy system, current panels, inverter, turbine, and batteries used in the project, which were deemed the best by our project partners. And we found that the cost of these power systems, not including the labor to set it all up, and also not including various minor installation components, at an inland point such as this would be roughly 45,000 euros. Of course, that's by all means significant money, but it's also important to note that renewable energy systems are decreasing in price in time, and also given that something like this is very low maintenance and can potentially run even for a couple of decades, this is, I believe, to be quite a worthwhile product. And the wonderful part about it all is that this is for an inland point, quite deep into Latvia, for a more windy area, and for an area with a slightly higher solar potential as well, such as this beautiful city of Ventspils or any coastal region. The results are even much better, as we had mapped during the early stages of the project. The coastal and the offshore area has I'd say roughly 1 to 1.5 times more to 2 times more total power generation potential than, for example, a point that is deeper inland, than, for example, the valleys of Gauja, the river Gauja, which were found to be of much lower potential. Therefore, this sort of infrastructure could be particularly strong in the coastal and offshore areas. When we had mapped the outage percentage using, again, the same system that we're using in the inland location, using the same power consumption profile, we found that in the coastal and offshore regions, the power outage would be of this system would be 2.5 to 4% compared to, again, locations that are deeper inland, which reach up to 10% up to a 10% outage percentage, which further shows how much better such systems could work near the sea. So finally, moving on for results at a coastal point, I chose a point at the very coast, roughly between Ventspils and Liepāja, near Pāvilosta, in the center of this western part of Latvia. We found that the average power outage time is more than 2 times lower. Again, we have the same problem that during the winter months it is higher. However, in total throughout the year, it would be only about 2.6%. And also, again, trying to find the most efficient setup that reaches a 99% uptime, the needs and the cost would also be much lower. Solar power would merely have to be about 25 kilowatts. Wind power is roughly the same. These same 5 to 6 kilowatts would do, and a battery capacity of 47 kilowatt hours, which would create a total cost, a significantly lower total cost and just a slightly higher cost than at this current location of 38,000. And such a trend of the price being much lower is visible all throughout Latvia. This project is still currently ongoing, so we're working on adding more points and adding a proper interpolation throughout all of it. However, in a map like this, with the points that we have, it is very visible that at a coastal, at an offshore, at an offshore point, this system would be much cheaper and work better. So to conclude, I think the most important takeaway is the fact that the idea of an autonomous renewably powered communication tower or anything of a similar power consumption profile is not only technically feasible, but also genuinely promising for the future. And even with its limitations, even with a limited size turbine at a limited height and then undersized battery bank, the system works decently well. And if we found that the system works decently well at the inland point in slightly, I guess you could say suboptimal, at a suboptimal location, we can infer that the system would work even better at a coastal point, for example. Which brings me also to the second major conclusion, that location matters more than anything else. The difference between central Latvia and the western coast is quite enormous. Coastal regions benefit very significantly from a higher wind potential, which in turn drastically decreases total outage times and the total cost for ensuring these low outage times. And the third and maybe slightly less important conclusion is that autonomous powers of this sort are incredibly important, especially with our current geopolitical situation, due to this signal interference being increasingly common. Therefore, improving resilience in these coastal and offshore regions is crucial. And as for future research, there are several ways forward. The most important one would be that after this tower is fully set up, after the turbines starts running and the power starts being generated, we would have to compare these real life data to our simulations. It's one thing that everything works well in our computer, but validating all this data against the actual model, real weather, real power systems, and the real hardware quirks that always come with this sort of project will certainly help refine the methodology and make the system better and more robust. Another direction would be expanding this research for infrastructure of different consumption profiles. Communication towers, which we focused on, are just one example. However, as I previously mentioned, any monitoring stations, navigational beacons, offshore sensors, coastal radar equipment, and other similar sorts of low to medium power infrastructure all have different energy needs, and quantifying exactly what those needs are and at what times and what is the most optimal way of ensuring the proper working of all this infrastructure is something that I think would be extremely valuable. And there's also room to explore, let's say, more advanced forms of optimization, making sure that the system works well also for near future weather forecasts, also integrating small scale backup systems such as hydrogen storage. That was another point of point of research during this entire project. And of course, also extending this model across the entire Baltic region and even to the island territories as well. It would also give a broader understanding of where these systems could have the most potential and where they could be the most impactful. So thank you very much for your attention. There's
Yeah, just a comment.
Yeah,
When
please.
I saw your graphs, I thought if we could produce energy from the darkness, then we would be very rich country.
Unfortunately.
What is actually mentioned is that we understand how to make use of all that gray and dark blue.
I'll work on it, I promise. It's coming.
Actually, so to comment from my side, so we are in Ventspils University and Ventspils International Medicine Center, and one of our activities is study of black holes, like the most darkest objects in the world in the universe. And actually, so maybe it's not now, but in part of our future, it's an enormous energy source which could be used and very compact as well. But it's probably not in 100 years or maybe even more at the time, but it's part of the future. Thanks again, and some questions from my side. This solar panels, it's 25 kilowatts. How big are they? It's around 25 meters.
Sorry, the area? That is, for context, you could think that one of these solar panels, which were used for the project, is 450 watts. Therefore, it would be roughly 50 of these panels. How large a panel is
Square meters and around 50 square meters. Square meter. Yeah, so it's big one. Yeah.
It is certainly a significant area.
Yeah, and it's again a nice result. But coastal areas is most promising for these autonomous systems. But probably if you go far away in a sea, it's additional expenses for deploying towers and solar panels on a platform or something like that.
For sure, yeah.
Additional pricely, but it's probably not needs so big towers and not so big solar panels. Yeah. Yeah, thanks a lot. And yes, please.
You're experimenting with the turbines, so what's the type there? Are you doing horizontal axis or vertical axis?
In the project, we found that the typical the typical axis that I'm currently forgetting, I think it's the horizontal one now, which is used for most wind turbines, was also the best one for this application.
Yeah, thanks a lot. Yes.
Another small question. Is any interest in a component from sea?
That would be another potential line of research. During this project, we have not done any research on that. However, that certainly has a lot of potential, and that would have to be looked at.
Actually, in my presentation about linear generators, I have a couple slides about wave turbines as well. So I will explain later.
Okay, so
yes. So thank you for coming and your certificate.
Thank you so much
for your talk. Thank you. Thanks again. And any activity from participants online? So if you have any questions, raise your hands, make notes in chat, or just turn on your microphones. But now I continue with our next speaker. Uldis, are you here? Yes, I see you.
Hi.
Good morning. So I think I can give floor to you, please. So I have your presentation, but do you mind to share your screen, or I need to run it?
I think I will share the screen. It's probably both a bit of time, but we have plenty of time.
Mm.
And
We save some time.
and also, yeah, and also maybe I will share the entire screen, so it will be a little bit. So then I will put it in full screen mode, and maybe.
No, yes, perfect. We see your screen. We see you.
Yeah, maybe you don't screen some logos, yeah.
We see everything. Yes, thanks. So here you can start. Yeah, I turned my microphone off.
Yeah. Okay. Thank you very much. Thank you for inviting to this Marine Technologies workshop. And my name is Uldis Bethers. I'm director of the Institute of Numerical Modeling in the University of Latvia. My background is physics, but mostly our group is doing numerical modeling of almost everything. Yeah, but one of things is oceanography, and particularly operational oceanography. And if you do some marine modeling, then from this you can develop some products. And one of such technologies which addresses coastal zone of Latvia and port areas, including port aquatories, is an information system Hivasport. I will show what is it, what's behind it, and what's new in it. This system is developed by the help of Copernicus Marine Service. There is user engagement projects running occasionally. The main thing is that Europe has quite good Copernicus services, both atmosphere service, marine service, and other services. But the results are quite complicated and require some special skills. In our case, we use them as boundary conditions. Okay, so the idea of this Hivasport product or service is quite simple. By the nesting of models, we can blend together what's happening in the sea with what's happening inland. For instance, in river estuaries, in port aquatories, and so on, you see these small places, for instance, here Riga harbor, where we have marine model outside and some riverine model inside. And also in the modeling community, sometimes these two people don't speak to each other, groups of people, of course, or groups of researchers. People who are doing ocean never do rivers or lakes or estuaries or whatever. Anyway, if we go for the summary of this system, then recently by my time scale means few years ago in 2024, 2025, we developed two new downstream services in our Hivasport system, of course in Baltic Sea, in Latvian waters. We developed this blending or seamless transition between the sea and inland waters. And second thing, we did something for the sediment transport in coastal zone. And in this system, we also have some observations by port authorities and third parties, for instance, Latvian Environmental, Geological and Meteorology Center. And here is the link, probably, if you wish, but you can access it through Water LV. It's quite easy to find. Okay, let's see what technologies are behind the scene of this online system. We take two Copernicus Marine Service products, which are called Baltic Physics and Baltic Waves. These are operational forecast products, and we took just boundary conditions from them. So the outer points and time series, of course, of them. When we run hydrodynamics in our modeling domain, it's Hiram Boost model in operational setup by University of Latvia. So it's run on our premises on, we can call it supercomputer or computing cluster of my institute. And we are also a member of Hiram Booth modeling consortia, and hopefully this Hiram Booth model probably will be open source. It's in transition at the moment. Whatever is the model itself, the main problem always is to implement, set up, and customize the model. We have did it for parts of Baltic Sea, except Botnian Sea, Botnian Gulf of Bothnia, and yeah, that's it. Sea and some Danish waters, but Botnian Sea, Botnian, we have 7 levels of Bothnia in our model. Yeah, that's it. It means that and some Danish waters, but from nautical mile in far sea down to tens of meters for inner ports where berthing places and maybe some shore areas is very important. Then for waves, we use in-house model for port aquatories and do not calculate waves outside, just use a Copernicus product. And these days we are developing artificial intelligence or better neural operator model for operational calculation of wave fields, because strange as it can be, modeling of wave fields nowadays is more computationally expensive as computation of hydrodynamics, mostly because of very fine meshes which are needed for discretization of computational domains. Yeah, okay, and for sediments, we use Hiram Booth model. There are appropriate models for the sea in our setup. And in-house sediment transport models for the coastal area where we calculate longshore sediment transport in wave breaking zone. Of course, setup of Hiram Booth model doesn't allow to account for wave breaking, which is sometimes happening in depths of tens of centimeters. So it's about models behind it, and now let's go for the services. One thing is seamless transition between the seas and the inner ports. As you see in photograph, the sea weather can be quite different behind the wave breakers. You see this wavy conditions outside and quite calm sea inside. And if you go for navigation, when captains of ships encounter a rough change of sea state at the sea gates of the harbor. And this is a part where most of the traditional models fail to provide a good solution, because you model either the sea and put the boundary conditions at the sea gates, or you are modeling the river or estuary or port aquatoria, whatever, and put your boundary conditions in again at the same sea gates. And so we try to use this nesting, which is available in Hiram Booth model, to overcome this problem. And in our model, when this transition between the open seas and the inner port is quite seamless. For waves, currents, sea level, sea temperature, salinity, and wind is not in our model, but it's very important for the navigational purposes and other port operation purposes. And if there are some observations, of course, it can be meteorological stations or wave rider buoys, as it in Liepāja Harbor, and I think also in Skulte Harbor, then they also can be included. So let's see how it looks like. For instance, I will show some examples on Liepāja Harbor. Liepāja Harbor is quite interesting because it has 3 gates: Northern Gate, Main Navigation Gate, and Central Gate. Here you see the wave field by the color scheme. You see how the waves go inside the aquatoria, and you see that there is no disruption, and more or less it's smoothly these models represent the wave field. Despite that outside we have Copernicus product, and inside our wave in-house wave model. And you also see that wave field in the harbor may be quite unpredictable if you just go by common sense without modeling. And it's quite good to have 2 days ahead forecast for planning your berthing operation or some movement of your vessels inside the harbor aquatoria. If it's a port like Liepāja, where huge territories are exposed to waves, you see what they have built internal wave breakers and jetties just to protect berthing areas from sea waves. Yeah, and here, of course, you have northern winds, and it's not the most dangerous situation. So let's go further. Here is example of salinity and currents. It's also somehow quite interesting because in so-called commercial channel there is connection between the sea and Liepāja Lake, which is also modeled as a reservoir, is quite good, but it's shallow lake. But we model hydrodynamics also there in MarTe River. You see the plume of brackish freshwater coming out of the lake in this situation. There are some westerly wind situations when seawater can intrude also in the lake, but it's not the case in this modeling scenario. You see also that here is some transit flow. In probably the water is entering the northern gates and flowing out through central gate and this one. By the points here are shown some specific points of interest or observation stations where some data can be also shown as graphs. Let's go further. Here is an example of a graph at the main navigation gate. At this station, Liepāja Harbor has installed a wave rider buoy, and you see by dots in this graph the wave height, measured wave height and wave direction, and by continuous line you see the model results, which also somehow helps for validation if you go to study this for some scientific reasons. Yeah, and model performs quite well, but I think it's not a story I'm going to tell you today. The next graph is some example of water level. Water level is also important, especially for smaller ports where low water levels may limit the passage of the ships in the sea entrance channel, and also loading of the ship, how much you can load in it, if it's because at lower water levels you operate in more shallow conditions. And here again are 2 water gauges. This is in the lake. as you see, the lake experience quite smooth and stable water levels, slow change. And then there is fluctuating seawater level, which is lower in this case. As you see also here, the water is mostly flowing out of the lake. But here, previous to current time, there have been some moments when water is flown in opposite direction, therefore you see salinity, which is non-zero here, yeah, in the navigation channel. Yeah, and the solid line is hintcast and prediction of the water level by the mathematical model, operational mathematical model. So let's go to the second service, which is new in this Kiva Sport system. We are the nice words is supporting of coastal management and marine conservation in Latvia. And the things we are showing in the system are also listed as seabed disturbance indicators in the coastal zone if you go for a different classification of processes. But actually we do two things. We included the operational map of sediment flux density just to see where and how is potential sediment flux in the Baltic Sea. And another thing, we put some mesh of points along the coast of Latvia for calculation of longshore sediment transport in multiple locations. Yeah, and then we can see how this longshore sediment transport can be compared with climatic values like seasonal and annual cumulative values. How this season compares to the 20 or 30 year long climate of sediment transport. Okay, I will show you how it looks. Again, we have plenty of these points or regions. There are some pictograms on the screen. For instance, we can take Ventspils Harbor. It's somewhere. And then we have this sediment, longshore sediment transport cross sections, which are also somehow named. And on one of the fields which can be shown in the open sea is the density of the sediment flux in some units, which seems strange, but it's the only meaningful units if we go for sediment transport. And of course, more sediment transport is closer to the coast. There is a wave action, the typical mechanism how the sediments are moved in the open seas, but waves mobilize the sediments and then the currents carry the mobilized sediments away somewhere. Typically in longshore direction, because the currents cannot cross the sea land interface, and so they are always parallel to the coast. If we go for cross-shore sediment transport, for instance, taking this profile, it's a vertical. I'm sorry, it's a cross-shore profile which is perpendicular to the coastline, and we calculate the longshore sediment transport. The longshore sediment transport is the feature which dominates the sandy coast, and Latvia has sandy coast, of course. And this sort of phenomena occur because part of the wave energy, especially in wave breaking zone where this energy dissipates the most, is transport to the so-called longshore current. So this wave energy does two things. Breaking waves create suspension of sand, and part of it, part of this wave energy transforms to the current. It's a dangerous sort of currents which carry away swimmers as well. And this current carry away along the coast also the sediment. Yeah, and for each of these cross-shore points, in our case, we took sediment load at Majuri, we draw 4 lines. We have pre-calculated the climatic sediment transport in eastwards direction and in northwards direction. You see that most of the sediment is carried in towards Riga at this Majori point. And when we calculate the sediment load which happened during the last year, I prepared this screenshot in April, May 2025. And in that time, we can see that this sediment transport in eastward direction was smaller than sediment, or of the same magnitude as sediment transport in westward direction. And we also could see that the total sediment transport was smaller as a climatic value. And if you remember last year when there was a quite strong storm in 30 of, I think it was 30 of July 2024, when there was a big damage in Jurmala, where also the farmers complained about loss of crops in Zemgale region, and it was heavy thunderstorms, rain, and northern wind. And this profile was exposed to this northern wind blow in this direction, so the sediment moves to westward, and it's this very big event. And one can see that all events of sediment transport, most of the sediment transport occurs in the event, like here, and so on. Yeah, okay, let's go further. It's the same for in the seasonal. Time scale and season in this case is 3 months from the current day, and where again in April 2024 there was a small storm which can be shown here. And yeah, one can see how we are doing in the climatic context in different places. Of course, for ports, it's also important because there is possible to relate this information with siltation in the sea entrance channel, which is one of big issues also in your port city. So what else? Yeah, thank you for attention. I think I also saved some time for questions. You can access the system at this address, WaterLV Hivasport, or you can go for WaterLV to see some other free products by our institute. I don't know why people advertise free products, but I'm doing it at this moment. And if you want to learn what we are doing, you can visit our webpage or write me an email. And I also, well, last but not least, I also invite you to one conference in Riga, August this year, Artificial Intelligence for Inland Water atmosphere and ocean if you are interested. So that's it. Thank you.
Thanks a lot. Thank you for your talk. It was very interesting and interesting products what you are delivering. And I understand this is already online in Water LV. Everyone can use it, right?
Yeah, it's online, and I will stop sharing. This system is online, I think, for some 5 or 6 years. We have also some user community. It is free, and it is free mainly because our main profit is from developing to put in place some subscription system where you get 5, 10, 20, or 2,000 euro per user. It's not easy, and it is also harmful for your public relations.
So yeah, but thanks a lot. So it's interesting. I have a couple questions. Maybe if any from audience, no. Online, I saw also no hands. But about prediction. So this system can predict up to 2 days, as I understand correctly.
More precisely, for 54 hours, but it depends.
But it also counts some kind of extreme events like storms or snow melting and floods, or it's not included, or it's not possible in this
Yeah,
case.
everything of it is included, but in the system there are parameters which are listed. There are marine parameters mainly, and from atmosphere parameters there are just two. It's wind speed and direction and air temperature. And if we talk about sea ice, I think it's oceanographic parameter. There is quite sophisticated data flows. We use numerical weather forecasts plus Copernicus boundary conditions and Copernicus wave field in OpenSea, and then we run our models. And of course, with operational weather forecasts, operational Copernicus products, and operational wave fields have this future component of, say, 60 hours.
And for inland waters, it's the same models or it's something different?
Yeah, it's we run a nested Hiram Boost model.
Yeah, thank you.
Okay, what I'm showing, everything comes out from our models. We use this atmosphere and Copernicus Farsi points as a forcing. So it means 4 times a day in our computational center, we rerun these models for the next 54 hours. So it's routine task, which is maybe not that typical for university. But this system, once it's set up, it runs. You need not to put much effort.
And covering it's cover Baltic Sea or just Latvia, Estonia?
The model, the model area covers most of the Baltic Sea, but the visualization area, which is or this front page you see covers a limited part of Latvian coastal area and limited number of ports. And we have 8 ports included in our system. And only for 3 largest ports, we have also hydrodynamic model inside. It's for Liepāja. Obviously, you saw it, yeah? For Ventspils and for Riga. In our hydrodynamic models, we run also Liepāja Lake, Ķīšezers Lake, Jugla Lake in Riga. and also Daugava starting from Riga hydropower plant and Lielupe River starting at upstream point near highway to Ventspils Bridge. But these parts are not included in visualization because it requires some effort in data transparency.
Thank you. Maybe one more curious question about sand and seabed movements. Is it constant? So in your plots, it's like a average per year, some cubic meters. I just worrying about Ventspils. So is it all time same direction and like a sand moving?
No. At every moment it's in different direction, but most of sediment movement occurs during strong events. It's if you are looking for operational things. If you are looking climatically, then of course these lines become smooth. Because in climatic means every winter day there is chance of a storm.
Yeah, thanks a lot. So if no questions, so thank you again, and we go to our next speaker. So
Thank you.
yeah, in our program, Andris Krauklis, Latvia University of Life Sciences and Technologies, and he will make a talk about modeling hydrothermal aging and degradation of polymers. So we have here. So the presentation should be on. Okay, so yeah, floor is yours.
Thank you so much. Yeah, can you hear me well? Is it working? Yeah, perfect. So my name is Andris Krauklis, and I'm an associate professor at Latvia University of Life Sciences and Technologies. And there a bit of an echo. No worries at all. So yeah, and basically, so what I'm going to talk about today is the hydrothermal aging and degradation of polymers and polymer composites in relation to that. And how do we model this using physical methodologies, so physical modeling and multi-scale modeling approaches. And then without further ado, let's look into the technology that we have to offer here. So let's start with the big picture. So the introduction is that, let's say, polymers are everywhere in our modern life. So they're also environmentally, they can be exposed to water and humid air environments, especially in our climate. It's also the temperatures and let's say the cold and so on. So there are really a lot of issues that come with the environment. And we are also looking into the aging of polymers with the effect of temperature and the effect of, let's say, humidity, the presence of water, the acidity, and so on. So all the environmental factors that can be there and affect the material. Looking at different polymers can be quite different from one to other, and we'll explain in which sense that is and how that can come into hand when analyzing the behavior. And also that means, however, that while the materials can differ, it means that the aging mechanisms can differ also quite severely. So all of that has to be assessed individually. And in case of polymer composites, it's not only the polymer, but it also is a reinforcement material, which is typically, let's say, if we're talking fiber reinforced polymer composites, then it can be a glass fiber or a carbon fiber, or more recently, natural fibers and basalt. And also there's the third part, the secret ingredient, the sizing of the fibers, and then therefore also the sizing rich interface, which can also affect the aging of other constituents. So let's take a look how we can, let's say, work with this very complex interaction. And let's say, to break down this complex, let's say, process of aging and all underlying processes, we try to build a multi-scale modular approach. So to break down a very complex issue into smaller pieces and to try to analyze mechanistically how each of them is working. So let's look into molecular mechanisms, kinetics, and interconnectedness of the constituents. But also, why do we need that? So in the modern times, let's say, it's especially important to understand the lifetime of a material. So how long does a material survive and can be put into use? For example, we're looking into towers, like wind turbine towers. That is something which currently is an issue in Europe in a way that with the recycling, because in real life, these turbines can live much longer than they're actually commissioned before. So because we are over, let's say, we don't want to risk anything. That's very smart, but that means that also we lose 10 years of real use of a turbine, for example, in the practice conditions. And the problem at the moment is also what to do with the, with the material that is waste, because composite recycling technology is still being developed very, very eagerly, but there are a lot of problems still. So lifetime. So now, as you know, life cycle assessments, that's a hot word, life cycle assessment and cost analysis, LCA, LCC. And we want to have a method reliably to predict the lifetime of polymers and polymer composite materials. And in order to do so, we propose the development and advancement of the modular modeling framework, which is presented here. And also we look into one case example, which is, so I'll go a bit into more detail, QSPR methodology that we developed to looking in the case of a PLA polymer and environmental agent of that. So lifetime prediction. As I said, the process is very complex and can be broken down. So the interaction between the polymer and the environment can be broken down into many smaller parts and parameters. So environmental factors, temperature, moisture, pH, mechanical loads. There's a lot of inherent processes, physical aging, hydrolysis for some, post-curing, internal stress relaxation. And we have to look also on different scales. So it is something happening on the molecular scale, the micro. Then it is the engineering properties that being affected, the macro properties that we're looking, and then there's the bridge connecting it all together, the mesoscale. So also, in some cases, we want the material to degrade. So for example, if it is something like a compostable material, so we also have to know the composition criteria in that case. So we have to look at the two-edged sword. So in some cases, structural materials, wind turbines, we want them to stay healthy as long as they can. So it's a safety criteria we take into account in the modeling. We have biodegradable, biocompostable cups or something which have liner made of polymer. We want it to be able to degrade it fairly quickly. So that's a favorable decomposition criteria. Now, let's take a look closely into the composite polymer composites. So we have three constituents matrix, the polymer, respectively, reinforcement, that's a fiber, and the interface region. And then when each of these components is intact, in contact with the environment, there's plenty of various sub-processes which go on. So let's start. Mostly we concentrate on the polymers today, so I will talk about the processes which work and affect the polymer. And also a bit of, I will show the interconnectedness with the other modules, but let's look into that in more detail. First of all, let's say we look environmental issue We have a polymer which is immersed in water, or we have a rain, let's say wind turbine standing there and the rain is dripping and affecting the polymer matrix. So water starts to diffuse into the polymer. Initially, we have, let's say, a dry state, although here we have a true water content, so nothing in reality is completely dry, right? So we have a equilibrium with the air, humidity of the air. Then it reaches certain equilibrium, the saturation level, so the material, the polymer is completely saturated. In this case, it's a very common, the most common epoxy polymer used in the market, the Day2 epoxy thermoset. And so we can see it can take up about 3.5% water. And we can model this very efficiently, usually using Fickian law, so Fick's law, and typically for polymers it works quite well. There are some exceptions, of course, but Fick's law is usually the standard way. Let's take a look. If we have polymers of a dry state, then the saturated state with water, and then we want to see if we re-dry to the initial state, is there any change, for example, or does it, so is it the water content the only parameter that affects the property of a polymer, or something else is there? When we look into composites, the polymer composites also, it can be even more complicated that we have not a blue saturated line, but with time we can see that, for example, it can also drop. And I will explain why is that. Now, I mentioned that polymers can be different, and in terms of material-environment interactions, this is important because the hydrophobicity of plastics is let's say, the property that is interesting to us. And in some cases, polymers can uptake a lot of water and be swollen and can be affected by hydrolysis, such as nylons, polyamides and PLA. Although on the other case of the spectra, for example, polypropylene or polyethylene, they are very hydrophobic, so they don't uptake a lot of water at all. Next, when we have water inside the material, it can cause the plasticization, and also it can be inside, let's say, inside between the polymer chains and starts to swell, so increasing volume. And in some cases, some polymers are affected also by chemical degradation, so hydrolysis chain scission. When the water is inside, it can also leach out the chemicals inside the plastic, and that is basically the water diffusion, but the diffusion out. So it's the same principle. We can use the same Fick's law, but with the other direction. And the degradation and all this plasticization, swell, and chain scission effects, they also affect the mechanical properties and of the material. So let's take a look again at this example of the most typical Day2 epoxy resin. For example, here we have in one of our papers, we identified the weak spots where the mechanism happens of the degradation of the epoxy network. So here's a bit of an explanation what happens. For example, there's cross-linking, which affects the glass transition temperature of the epoxy. And so when we re-dry the material to the initial state, we cannot regain all of the properties that we had before the aging, even if we have the same content of the water. Then also, as we know, very typically, this is important for in art conservation, for example. So epoxy is a glue and used in art also as a, let's say, to protect the piece of art. With time, this particular epoxy and most of epoxies, they age and they become more yellowish or grayish, so they change their color. And the reason for that in this case is a carbonyl formation. So the oxidation that happens even with quite low temperatures just in outside air. So it's not by sun, It's not photo-oxidation, this is thermal oxidation. So to kind of sum it up for this material, this is just an example for one material, but every material is different, as I mentioned. So it can be a lot of mechanisms: plasticization, hydrolytic scission, thermal oxidation, in this case, changing the color, leaching, thermo-oxidative cross-linking. We can check all of that, let's say, with different methods as we go, so infrared analysis or so some spectroscopic methods. We can also test mechanically and see how the properties of a polymer, let's say in a dry, wet and re-dry state are changing, both statically and in fatigue. Then in terms of hygroscopic swelling, as I mentioned, so the water that is inside between the chains starts to swell the polymer. And this one is quite easily predictable, so we can use simple modeling tools for this one physically. It's almost like a thermal expansion, but it's just hygrothermal expansion. And this one can be done both analytically and with finite elements. With polymers, this is a linear correlation. For composite, it is orientation of the fiber dependent. But let's get to the more interesting part. So in this case, let's say how can we predict the property of a polymer if we don't have any testing facilities with us? So here we offer the QSPR methodology. So it's originally not ours. It's based on it's QSPR and QSAR. QSAR methodology is quantitative structure activity relationship. QSPR quantitative structure property relationship is something, is a method that has been developed mainly for drug discovery, so for medicinal pharmaceuticals. But it has been taken over also in the polymers and the material sector by DuPont. And the idea is that we have any chemical structure, and we can use the mathematical graph theory to analyze the Lewis diagram. So the graph theory allows us to break down any structure into a number of parameters. In this case, atomic and bond indices. So it's a 4-parameter. And with the mathematical operations, we have so these 4 parameters as simple valence and 0 and first order indices, also called structural parameters. And the interesting part is that these parameters, they are unique for any chemical. So let's say if you have one polymer or another polymer, they will never be the same. So that's what gives it a fingerprint. And by using this combination of these 4 parameters, we are able to predict the properties by using an extensive data that is available to us. And now with the modern techniques, especially with the data science and machine learning and so on, this method has been given a new life in a way. So also another way to look into the prediction of properties of wet, for example, so saturated polymers, and also the effect of temperature. If we have the viscoelastic effect, so for example, we have a material creeping over time. The principle of time temperature superposition has been known for years, and it means that for polymers, for materials which have viscoelastic behavior, we can superimpose the effect of time and the effect of temperature. So they, let's say, creep at higher temperatures, they creep faster. However, what we have shown also that the effect of water present in the polymer can also be superimposed on that. So we have, for example, the blue is the dry master curve, the red is the wet, the saturated polymer master curve. And the interesting part is that these 2 master curves can be superimposed themselves by using, as we call it, dry to wet shift factor, which corresponds between the glass transition temperatures of the dry and saturated states. So if you are interested in this, for example, what can this do? is that that's the graph on the right, for example, in one paper that we wrote together with our colleagues in Hamburg, is that it allows you to predict how long a polymer will survive under given water content, temperature, and load, mechanical load. And you can use it as a surface basically to predict, let's say, at 20 megapascal, it will survive for this many years. At 40 megapascals, it will be less, and it will be this many years. So that's kind of how it can be useful. For some polymers, as I mentioned, for example, this epoxy that we looked at, it doesn't go hydrolysis. But there are many polymers that are used in our daily lives, such as polyamides, nylons, for example, or PLA, one of the more common, let's say, first biopolymer in a way that is used a lot in 3D printing. They undergo hydrolysis with water, and it means that the reaction is typically non-reversible. So the properties can be lost over time until the material breaks down. So the hydrolysis can be predicted with such modeling ways, for example, the time-dependent decrease. However, let's look also in the case study, interestingly, to combine the QSPR methodology. So the way how we can predict the properties of a material from their chemical structure to further this approach into the aging. So this is something that has not been done before. We just published this last year. And this is basically the proposal that we had, in a sense that since the QSPR methodology can be used to link the chemical structure with their final properties, and we know, for example, how the hydrolysis happens, we know how the material will look as a structure, chemical structure after the hydrolysis has happened, and therefore we can put the parameters, the structural parameters of graft theory to the aged polymer and see how basically the end case looks like, the start case looks like, and then to using the chemical kinetics to get in between cases. So what this means. So for example, for structural applications, we can have Young's modulus being predicted using the cohesive energy of this QSPR structural parameter via the QSPR structural parameters of a polymer, in this case PLA. We know that the mechanism is hydrolysis of ester bonds, and then we use infrared Fourier transform spectroscopy to measure the change in the intensity of the peak and to see the reduction over time. And then this FTR data we feed into the QSPR model, and then we obtain the predicted mechanical properties. So, for example, this is the kind of results that we obtained. So, if FTR data with over time of aging of PLA in water is on the left, and then when we feed it to the QSPR, we're able to obtain the modulus. And this one was compared with the experimental, so it was validated. And the validation was looking something like that. On the left case, we have only aging. On the right case, on the right side, we have also recycling. So it was a little bit, we couldn't catch the effect of recycling with this, which was not that surprising because we have the hydrolysis model inside. And recycling is something in plus that. But let's say the QSPR was able to capture the decrease of modulus for pure aging. Now, if we take a look a little bit onto, let's say, the expansion of the aging of polymers inside the composite. Here, for example, we have a polymer composite aged for 9 months in 60 degrees water. And as we see, the mass keeps dropping. So what is happening there? I promise to come back to this one. So if we take a look at the same principles of, let's say, polymers and interface, interface is mainly made up of a polymer itself, but different type, and also the chemicals that bridge the fiber with the matrix. Typical interface composition is about 80% film formers, coupling agent about 10%, and other chemicals for about 10%. The film formers are polymers, so it's about 80% polymer. And typically these sizings, they can also be degraded with time. It's also very small amounts, which is on the fibers. Therefore, it's really hard to measure experimentally, but we try to use the chemical engineering principle of mass balance approach to get it. And if we look, let's say, how big is this interface? Is just barely less than a nanometer. So experimentally, it's very tough to look into this covalently bonded part. But also the one which is called the interface, right? So there's the difference between the interface being 2D and the interface being 3D. It's kind of like a mix of this film former together with the matrix. This can range up to 500 nanometers, but it's it's quite rough surface. So by knowing all of these processes that we have described, sub-processes for polymers, we can try to make mass balance approach. So if we have a gravimetric measurement and we know all the sub-processes that we have obtained, then the only parameter that we don't know is the dissolution of the interface, and therefore we can try to obtain that from estimate. That's not a very precise method, but still we can estimate the aging of interface. What happens is that, for example, we can see that the photographs, the micrographs of the composite and how it starts to degrade after a long time. As I remind you, at 9 months at 60 degrees water, and how the fiber matrix starts to debond and the cracks start also splitting along the fibers. So there's the interface which being filled in. So there's like a void being made. And if you see the dotted line, that is when the saturation with the Fick law is obtained. But what we interestingly see is that based on the composition of the fibers, and then you see the longitudinal and transversal fibers, the longitudinal, they start to increase in mass. So the water is being uptaken for 9 months. And for the C3, we saw that it keeps decreasing. So it's quite small, but from 0.96 to 0.87, but this is not statistically significant. And we found also a different source in literature by Peter Davis at Ifremer that they found a similar behavior. And what happens is that the composite, it keeps degrading, and they're like a pores, like voids that are becoming inside of it. And these pores are being filled with water with time. So it's not like it's chemically or physicochemically bound, but it's just filling the voids. And therefore, we have this increase in volume. However, when this volume starts to connect together, they make a channel. And this channel can leach out this water outside, and we suddenly lose this mass. And this is for C3 composition for the short fiber for the transverse. It happens very quick. So we can see that we don't see an increase of weight uptake. And it straight goes to the degradation. So here, for example, data from Peter Davis is 10 years. So you can see that it's a composite which is in 60 degrees, for example, for 10 years straight in water. So it's a long process. And as I mentioned, temperature accelerates aging. So if we have 20 degrees water, for example, it's much slower process, but it's still the same mechanism. Interestingly, so I'm coming close to the conclusion already about, let's say, these various methodologies that we have inside this package. So with this with the mass balance approach, that we looked at, we could obtain, as I mentioned, very rough estimate of this kinetic constant of the degradation of interface. And it has the same, so we have three scenarios because, as I told you, sizing is hard to analyze experimentally. So based on the models that are available in the literature, we had three scenarios. And in all three cases, so the scenario one is very improbable. That's maybe a little bit, yeah, I have to go into too much detail maybe. Why is that? But the idea is that basically, so in short, is that it depends on the coverage of the sizing, how it is distributed, and also basically this profile of the fiber being aged with water, being attacked by free water. So the first case is not very probable, so it's most likely scenario 2 and 3. But in any case, this gives us some boundaries of the, let's say, degradation time from 22 to 30 years of this typical composite at 60 degrees. And interestingly, that this kinetic constant that we estimated for the degradation of the interface is very similar to the degradation kinetic constant of glass fiber, which makes sense because it's silica or silica bonds that connect matrix and fiber. So to conclude, basically, I would say that we have proposed this modular approach, and I apologize, it's a lot of information that we tried to put together. It's many years of things that we tried to do. Basically, it's that we have a complex process broken down into smaller pieces. We try to attack each of them individually, and then we obtain this physical-based models for each constituent, and we try to, let's say, make a framework usable for as many different combinations as possible. So this framework was actually implemented in a marine composite standard by the NVGL, so the Noshke Veritas, and they use some of our models in the standard practice. So these quantitative models and methods, they can provide practical tools for the industry. And the main idea is that in our modern age, in a way, that we try to replace as much testing with modeling which we trust, let's say. Let's put this, that we can be confident in. So if we can be confident in the method, we want to replace the testing, because the testing for the industry means a lot of money. So for example, when they introduce a new composite material, it can take at least 1 to 2 years in a full like testing house. So they book a testing house for a year, and it means millions of euros. For new companies to introduce new materials, it means that they have a bottleneck. They don't have this money to introduce new material. So even by substituting the rigorous physical testing by 20–30%, maybe we can cut the costs by 200–300,000 euro, for example. So this multi-scale approach then provides the means to analyze the environmental aging of composites. It can also be used, I didn't write it here, but it can be used for looking into the microplastics, right? So the microplastics being generated by the aging of polymers. We can use the physical modeling also approach to give a bit of the mechanistic look into this process. Yes, I would say that future work should include the improvement and the interconnectedness of these modules. And we still have some limited understanding of the interface, in my opinion, but this is, let's say, something that the whole composite material is working on. So thank you very much.
So comments or some questions from my side?
Yes, please.
Maybe
you focus on the PLA because of the state of the office. More like
so the PLA was it was basically in a consortium that was done about recycling of polymers, and it was in collaboration with the 3D printing. So they are very much interested in, let's say, the ABS versus PLA, the kind of typical old school polymers being printed. So PLA was chosen for this one, being the greener one of the two. Yeah.
Yeah, and some questions from my side. When you're testing these samples, how big are they? So it's like a nanometers or centimeters?
Yeah, so it depends which test, but let's say I have one picture here with the size that is for mechanical testing. So here we have a dog bone shape. This is something that we do for establishing the stress strain and the fatigue. Yeah, so that was pure polymer. With the composite samples, we usually do 3-point bending, so we don't strain them, typically a bit more complicated. We have how it's called, like I-beams, for example, like profiles.
And one more, this is water, just pure water, or it's some kind of salty water, or
yeah. So in this case, I didn't want to overcomplicate it. It is pure water that we look. So it, the ionized water, yeah, basically like a distilled, pretty much. But also the effect of pH and the effect of salt, for example, it all affects the degradation for some cases. So it can affect the speed. In this case, we didn't look into that. However, more interestingly, it affects more the fibers than the polymers. So, for example, if we have glass fiber, then the aging of glass fiber will be very strongly affected by pH and salt.
Yeah, so probably if you go into wind industry and blades, which is glass fiber and composites, so this is exactly what I'm trying to find out, how long they are become degraded.
Right, exactly. Yeah. So we want to know the lifetime and how long, let's say, how long is it safe, and we are confident that we can use the material, and also let's say we have to understand how does it degrade, right? If we want to be confident about it, not to have any surprises.
Yeah, and if your slide was like a 22, 30 years, it's exactly about composite materials.
Well, that was about interface, but if the interface fails, then the composite material will no longer be usable. But this is very much geometry related. So if you take a different geometry, it will change the number. So individually, we have to include this information, let's say maybe in finite elements, to have the geometry.
But again, in real life, we have like a frozen water and melting water, so it could like intensify process of degradation.
Yes, so that typically here, the higher the temperature, the faster the reaction with Arrhenius approach. But if it is frozen, there's the freeze thaw. So if it goes around the 0 degrees, it's another process which here it's not included, but it affects mechanically damaging the material. So if it is the ice that is being built inside, and currently there's also research in the cryogenic aging of composites, especially interesting for aerospace. So they are looking very much into these freeze thaws and very low temperatures, and also a little bit in the Arctic, like -40 degrees, for example, or something around that. They look how does it, the brittleness, the aging, and so on, how it's affected.
Actually, it could be very interesting for us, exactly cryogenic systems, because in our radio astronomical telescopes use cryogenic receivers, which are cooled down up to 20 gallons in less, and how plastics will survive inside, it's a good question.
Yeah, so the typical problem, I would say, is the cycling. So it's not maybe the temperature itself, but it's the change of the temperature. So it's like, especially if it changes quickly from very low to higher and then again. So these cycles, the thermal shocks that are.
Mostly for aerospace, like satellite.
I would say so, yeah, but still, like also hydrogen, liquid hydrogen, the containers, the vessels, the pressure vessels that are being. This is also a topic which is where this comes in.
Yeah, clearly. Thanks a lot.
Yep, please ask.
Good question.
Yeah, sure.
Have you introduced tribal physics into modern analytical application?
No. To be honest, short answer is no. We haven't looked into tribal physics here, but it could be certainly for the surface. Like we were looking more into bulk, but I imagine that it could be like let's say some defects, right, that can be made on the surface, which can then start the crack, which can accelerate the process, for example. That can be, yeah.
Yeah, but I mean, because we have a very tight temperature gradient, but we need to kind of go to the gas, right? But what about the type of this? Because also this kind of things can make some kind of impact. Maybe first to that, we could think that this the impact on the device.
Right.
But certainly, for example, we have a storm or like that. Out of the stress that we need also the electricity.
Yeah, certainly it could be looked into it as well. I think here we kind of we're looking more into this bulk materials in a way that industry wants. They don't, kind of closer to the real life, not laboratory made material in a way that they want. What I mean by that is that, for example, industry. Well, if it's not aerospace, which then they're very careful, but let's say it's something like a wind turbine. They just make it in one go, like the whole turbine or something like the whole chap. And so the process is not perfect in a sense, like it's not laboratory controlled, So we want to have this kind of real life relevance in a way. But I don't think they would check, for example, the tribal, like the whole surface, But it could be in the future, like with Aeronas, for example, that they have these robots going on the blades. They could monitor maybe how the surface is as well, like with the future functionality. It could be the case for the future, I think. Yeah.
Okay. Thank you again.
Yep. Sure. We can do that.
And your certificate.
Thank you.
Thank you for coming.
Thank you so much. Thank you.
And we go to our next speaker.
Okay. Yeah. Thank you.
So
Presentation on Teams.
okay, so you'll connect to Zoom yourself?
Yes.
So probably I need to switch off your sound.
Yes.
Yes.
It's doing correctly. Right. Thank you very much for the invitation. I will present something a little bit different. This will not be a scientific presentation. This will be a path that we've gone through in the last couple of years, in the last 4 years to be precise. And this is a presentation about our attempt. I would say it's quite a successful one to commercialize something in the water sector that we have developed in the scientific sector. So I'm MarTe. I'm a leading researcher at the Institute of Solid State Physics, and I'm the head of optical materials laboratory. I usually, in my day-to-day basis, and in the last 13 years that I worked in the institute, I work with nanomaterials, I work with the preparation and more like scientific research. But this is a rare case that we had the ability to commercialize something. And I would like to share some experience of how it went and what went wrong and good or bad and what someone should do or shouldn't. The structure of the presentation is very simple, but first thing I would like to say is that this presentation is not an advice. Don't do everything that we are doing in the same way, because I believe that for every startup and every company that wants to acquire public funding or private funding or VC funding or whatever it is, the path will be very different. And also, I would like to say that for the Spectrum Marine, the whole company, the close ties with the academia and the research institutions are very crucial, and that's why I think that it's very relevant. I would also say that this presentation will cover the one of the hardest and yeah, sure, please.
So we need to turn camera here because you're also translating it.
Ah, I see. Okay, then I'll turn it
Now
on.
we will see you as well because
Okay, I see.
voice.
Yeah, all right. So there are many different ways to how to commercialize scientific results. I guess everyone is very familiar with a couple of those. Is patenting and selling licensing patents. I would much rather sell a patent or license it from the institute than do whatever we've done here. The same. So let's move forward. Right. Let's just look at the problem of water analysis as a whole. If someone wants to analyze water and determine the quality somewhere in any way, there are many different possibilities. Most popular one is just taking the sample and bringing it to the lab. We have many of those in our country that they will perform for a very low amount of money. A lot of measurements. However, the issue is that you have to bring the sample inside of the lab and you have to manage the samples, and you will lose frequency. But there are a couple of solutions, even drones and all the satellite imaging is very popular, where you can acquire a lot of data with much bigger frequency and with lower cost. But you will lose data quality, so nothing will compare to the laboratory data. So from the triangle, you have to always choose only two, either your data quality and data frequency, or other variants. And that's where what we try to solve with Spectrum Marine. It all started with our pursuit and day-to-day job of creating scientific setups. Once we had the ability to create a scientific setup that can be applied in field, so at TRL 5 level, this basically the whole concept for it. But we deliberately chose only the technologies that can be as low maintenance as possible. So from all the different methods of analyzing water, from the like manual sampling from the pH sticks and all the super expensive €100,000 sensors that use electrochemical analysis and everything else, we chose only the methods that can be used unattended for many months. And this is the idea. So Spectrum Marine is a metal box. You see it on top. It has a lot of electronics inside and optical systems, and also a computational unit. It is a fully automated unit that you put the whole box inside of the water. You connect it to the internet directly with the RJ45 connector, so it's like your router or web camera or anything like that. It connects to our databases and does the data analysis by itself, and you get the dashboard with data that's relevant to you. Of course, the frequency can be as big as you want, up to 1 Hertz. We haven't found anyone that wants this type of frequency for any even industrial process, but I guess we'll look further and we'll look at someone that will challenge us to the speed. But it will generate quite a lot of data by itself, even at like 10 measurements per minute. What it can measure, we mainly focus on the optical system. So we measure everything that has fluorescence or absorption in the UV visible and some of the infrared range. So chlorophyll, ficusinin, biological substances, all the bacteria that has fluorescence, be it pink phosphor-eating bacteria or chlorophyll, green, blue, whatever it is. Of course, it can measure dissolved organic matter, so everything that's connected with decomposed bacteria or something that, like the algae that didn't survive. It can measure some metal oxides because you can see that if your water is contaminated with iron, it will be more brown. It can detect that. It also has quite a strong UV irradiation, so it has the ability to measure hydrocarbons, so presence of oils and fuels and everything else inside of the water. And how does it work? It's quite simple, actually. This is the approximate excitation emission matrix for the chlorophyll on your screen. This is typically what you get if you want to measure fluorescence for the chlorophyll inside of the lab. So you have tunable light source and full spectrum measurement. And through measuring the spectrum with different excitation wavelengths, you acquire something like this, and it corresponds to different biological matter and processes inside of the bacteria. Typical sensors, fluorescence sensors, you can go to AliExpress right now and buy one for like $10. They usually use only one single excitation wavelength and one single measurement value. Some of the systems use couple of the excitation wavelengths and a couple of measurement values, but still it's a point measurement. And then you correlate these points to whatever you need, to like the chlorophyll or whatever it is. The issue with that approach and why those sensors are not frequently used for the very important industrial processes that this signal can be very much affected by other parameters like sun or dissolved organic matter background or anything else, and you will get false reading quite often. And what Spectromarine does, what we have developed, we've put a actual spectrometer inside of the box. So we still do multiple excitation wavelengths, but we measure full spectrum. So across the whole measurement range, we acquire quite a lot of data points. I think it's somewhere around 500 data points for each spectrum. And we then perform quite an extensive analysis and peak fitting. It's mostly peak fitting, but right now we are transitioning to more a database-based approach because we are approaching the amount of data that will allow us to do so. Then we analyze the data set as a whole. So we use different excitation wavelengths. We acquire a bunch of spectra. We acquire also data on temperature, salinity, and pressure. And then we do correlation with some calibration. We also developed our own calibration procedures because this is a nightmare to calibrate. This goes really bad, but if you solve it correctly, and we have a procedure for that, then it gets you quite an impressive amount of the results, right? And then, of course, we get the sensors, we connect it to the internet, it's all powered, and it sends the data constantly every second, not every second, it's every couple of minutes to our server. Then we do analysis on it, comparison with different databases, calibration procedures, and then we present the user with the graphical user interface, or most often no one wants to see this amount of data. They use it for the automation purposes for their processes. Well, so we developed the system inside of one of the publicly funded projects, and then we thought that what we would do with it, like whoever needs it, or should we even spend our time to massive amount of time to commercialize it. And the first issue is that you have to find a client, right? You have to find something that will catch this idea and put it to good use. So we got quite a bit of a list of parameters that you have to follow if you want to commercialize something. For us, the first question was the money directly correlated to the water quality? For example, environmental studies is not a sustainable business model because in environmental studies, if anything happens to water quality, it just happens, and it's bad for the people, and people will care, but it will not affect the main value proposition for a business, right? Is there a way to control water quality based on data? There are many processes where water quality can affect the business itself, but it's not correlatable to anything, so you cannot do anything with it. Couple of examples are fish industry in the coasts of Spain, for example. They got contaminated with pollution quite extensively, and they just moved everything to Peru. So they just didn't have the ability to solve anything. Can the pollutant be measured with the device? Let's be real here. This device doesn't measure anything and everything. It measures only specific parameters, only things that we can correlate to. And it's quite an extensive list of things compared to other systems, but we got very often asked like the questions if we can measure, for example, I don't know, uranium concentration in water. We can't do that, right? We can measure only things that have fluorescence or absorption. We are looking for places where the conventional sensors fail, and we have to solve a expensive issue. So the sensor is not a cheap thing. We have to get money from the business, right? So we have to solve an issue that's substantially more expensive than the sensor itself. So it's much more easier for them to buy the sensor. If you don't find a fit, you will die. In any business, it will just happen. It's not in the water sector, it's anything else. We of course looked at the fisheries, water treatment sector, where they have direct correlation to all of those parameters, fish farming, and farming in general in water, like shrimp farming and anything else, desalination, HVAC industries, and everything else. We looked at it, and we decided to start with fisheries. During the first project that we developed this device from, we connected with Pescanova. Pescanova is the largest shrimp manufacturer in the world. I think that there is a 30% chance that if you buy a shrimp in your supermarket, it comes from this company. So they produce insane amount of shrimp. They have like thousands of staff, and they have. It was very funny to visit their R&D institution because it was bigger than my institute, just for the shrimp. So we sent the sensor, we pitched them. They are always looking for those types of things, and we pitched them. They said, send the sensor in. We tried the sensor, we developed anything that we could in the institute. We tried our best to do it, and we got approximately 2 weeks of usable data throughout the whole year, because the system was actually trash. So it was so bad, it was insane. It failed in every possible way. Every component that we had, except for the window itself, broke. So we decided that we have to take a break from this approach, because we will lose this contact, because you have to make them. You can make mistake only once. If you twice make everything wrong, they will not talk to you again. But we got quite lucky, because another industry contacted us. They found us through one of the platforms that we were active from, and they contacted us and proposed another case for the sensor use. And the another case is the desalination industry. We are quite lucky here in our region that we have fresh water everywhere, and it's quite cheap. But for the Middle East and for MENA countries, it's for Saudi Arabia, for example, every liter of water you get that's fresh comes from the desalination factory. So it somehow went from the sea through the desalination factory and to your tap, whatever it is. So the industry is crazy huge. And they contacted us. They very quickly determined what the problem is that we can solve. And the problem is membrane biofouling. So most of the desalination plants, I would say above 90%, use reverse osmosis and membrane filtering for the water. So the idea is quite simple. You just get this membrane filter, and you put water with a massive amount of pressure through it to get the salt out, and then you get brine and clean water. And the main parameter that damages those filters is biological matter. So if the bacteria goes inside of it, it starts to grow in it, starts to biofoul and kills the filter, and this is a very expensive problem. And this is an expensive problem not only because you will have to pay 100,000 for a new filter, but because you will have to pay for the electricity for the increased pressure of the pump that you will have to push through the water, and you will have to stop everything to replace the filter. It's quite an expensive problem for them to solve, and the idea is very simple. Just put the sensor before the membrane filter, directly before it, but after the pre-filtration. Pre-filtration, in their case, if you want to create millions of cubic meters of water, is basically filtration with a lot of chlorination in it. So it's chlorine, and that's how they kill bacteria. We put our sensor after the pre-filtration, before the membrane filters, and try to determine where the biological matter starts to go inside of the filter. So when it fails, right? This resulted in quite a successful cooperation. We are currently have 2 pilots running inside of the Saudi Arabia in one of the biggest plants inside of the Arabia. But we just this year transitioned from the test plant to the operational plant. So it goes to TRL 7 now. And through this successful collaboration, we got the insight that this whole business thing might actually work, and we might want to pursue it further. For the timeline of the company and the whole process is it looks approximately like this. So we started with LEA project. It was mission C 2030, and it was in 2022. It was a 1-year project. It was quite rapid because it was just the timeline was very short. We developed first prototype that year and tested it. This failure with the fish industry and happened the same year. And we of course tried to do a patent on the technology, and it was submitted through the institute, so no company was existing there. We continued with Saudi Arabia tests in 2024, and at 2025 was the year that the breakthrough year that we decided that if it doesn't work out, it doesn't work out. Let's move forward. But we were I wouldn't say lucky, but we were fortunate enough to get an pre-seed investment from the Netherlands, from the NOM. So we got the pre-seed money from a Netherlands fund that is partly operated by private individuals and partly operated by the government. So they have a huge scouting procedure, and they scouted us, I guess, and gave us the money to continue forward and to pursue the idea that we can commercialize it successfully. And in August last year, we established the company in the Netherlands themselves. Intellectual property, couple of words, and then the next part of the presentation will be just the insight that we went through. Again, take it with a grain of salt. You don't have to relive it if you want to do something. And I completely understand anyone that doesn't want to do something like this. But intellectual, let's quickly go through a couple of insights from the business, right? Intellectual property, we got quite a bit of patents in the pipeline right now. But when you start in the academia, you have to always remember that the patents are very expensive if they are not needed. So if you want to submit a patent, and you have to clearly understand what will happen with the patent later on. Of course, there are a couple of programs with public funding right now that require the submission of patent as a deliverable. Just submit Latvian patent, the cheapest one, and forget about it in 2 years. Just do it. But if you see a proposition of value for business that can be acquired and costs money and saves money for them, you absolutely should patent things, right? And it will be quite a bit more interesting for the investor if they see a patent and value outside of your idea or concept. This what helped us. What's helped us a lot. And of course, patent only necessary parts. For the spectrum marine part, I would say only 20% of the IP is patented. Everything else is closed source. So this is just the state of things. Funding and business strategy. The lessons that we have learned throughout this journey is that if you can use public funding, use cooperation with industry and cooperation with institutions and with industry, submit projects, Biofox, LEA, Horizons, Eurostars, whatever it is, whatever your ambition is. Public money is very sweet, but the investors usually will ignore it. The in-house advantage, if you're developing something that's hardware related, that's at low TRL, TRL 2 or 3, that you probably want to keep everything in-house. So don't outsource anything that you don't need to outsource. We did this mistake and we outsourced a couple of parts, but the lead times usually is what destroy the progress and iteration. Constant client validation is a must for any startup. So just if there is no one to tell you that they need something, it's not because they don't understand. It's because they don't need it. So right. So this is you have to find something and problem that you can solve, and not look at your solution and find a problem that can be solved with this screwdriver or whatever it is. And yeah, business people. I'm quite far away from business talk at the level that the venture capitals and everyone else is talking, because I'm a scientist. And I frankly am not very interested in those. That's why business people are, if you want to commercialize something and you're a scientist, please employ a business person. It's a very different beast, and I wouldn't suggest any scientist to do business talks to his clients, right? And you have to have the right team. For the investors, we have a team of 3 people, 3 core members. For the whole company, and we've got the impression from the investors that it's like at the limit. If you have some more people in the company, you have to have very, very good justification why they are there. So don't take your whole project and move to the company. It's not a good strategy. What helped Spectrum Marine through all the journey is that we accidentally proposed value that we were too blind to see, because we are scientists and we developed a cool technology that can measure spectra and sense the data, whatever it does with the different algorithms and everything else. And the thing that clients mostly cared about is that it's just connectable to the internet, because they operate with the premise from other sensor manufacturers that if you buy a sensor, you have to buy a data logger, you have to have an engineer that will connect everything and do whatever it is, your proprietary dashboard that you will have to connect with some API, or it's a mess. And you will have to pay every step of the way. And for us, the main value proposition, it's not the main value proposition, the data is still the main one, but the big value proposition is from the fact that for the client, it just takes out of the box and puts it in the network and just opens the phone. That's it. This is quite a good realization. It's not connected with the core technology, but it's good to have. Close ties to academia helped us a lot. I covered it already. Work with the institutes. They are very much interested in spin-offs and commercialization of some sort, because institutions will show you to everyone that wants on the fence about giving the institution money, because they will show that we have some business and value here. So the institutions and the academia as a whole is a good also source of brains. The students, when they are graduating, they are usually the smartest part of the life. They don't want to expand their knowledge. This is the best time to get them. Very rapid iterations. Again, keeping everything in house helped a lot through the whole process. Through the 4 years of development, we've developed. I think this is the 9th version that we are deploying right now, and the 10th version by the way, will be made from the polyethylene, not the aluminum this time, because aluminum, if you want to deploy something in Black Sea, aluminum will be eaten away, especially if you have electronics inside of it. But yeah, so 10 iterations of the devices in 4 years is quite a lot. Oh, it's 8 generations. So, but the 10 is in the working right now. And good balance between all parts to make it happen. Yes, the early employment of early connection with business people that can push the technology to clients gave us the opportunity to see the motivation first, and get the proper deadlines, because for any hardware startup, it's very easy to lose yourself in deadlines and just forget about what you are doing and fiddle with electronics for 2 years. It will not happen if you have a Zoom call in 2 weeks with potential client that wants the device in April, right? You have to have proper strict deadlines. And again, this also means that if you develop a product, then you have a direct eye to look at it and validate it through the real case, right? Networking is key. It's just, I would say, from the hours we spend on the business itself, I would say at least 30% is networking, just talking with people, talking with companies, validating, signing all the paperwork, going to the Netherlands to some convention, or sending sensors to Saudi Arabia, solving logistical issues, looking at shrimp in Spain, proposing a Horizon Euro project with Portugal that we also participated in, sending sensors to USA just to know that OSHA will not allow UV sources inside of public waters to get it shipped back. We were working on that this year. Norway, where we got our first clients that paid actual money for the device. Baltics with the Interact project that is currently running, and we will also develop 6 of the sensors to be deployed in public beaches in Latvia and Lithuania. Singapore for the HVAC industry, Germany with the couple of 2 sensors currently operating in post-mining operations. So they just collect mine water and analyze it. Poland with buoy manufacturing that can do very good buoys, but want better sensors. And if you have something of value, you have to be where the most movement is. And for the Europe, if you want to work in water sector, Leeuwarden is the place to be. It's basically a water hub. It's like a Silicon Valley for water technologies. In Europe, there are quite a lot of companies there that have valuations of hundreds of millions of euros that just do water stuff. And we are established there. We were invited there by the Netherlands, the NOM itself. And also, if you want some contacts for the idea validation, feel free to reach out. We share contacts very freely. If you have some idea to validate with someone you want, feel free. We have quite a lot of contacts that can actually help you to get to know the industry better. Let's do main mistakes. First mistake, if you have decided that your text is TRL6, you can tell it to the client that this is TRL6 and even do free pilot. So you just give free device to someone and say that this is a lab example. This is like rough. This is TRL6, right? He will say yes. Well, 2 weeks will pass and he will forget about it. He will think that this is a product and it doesn't work immediately. So this happens to us a lot. If you want to like move something through the business structure, the person you will probably get in contact with is the R&D department person that understands what TRL6 is. But as soon as you send the first invoice, as soon as you try to do a paid pilot or anything else, they will forget about the TRL part entirely. So they will think that this is a product. Not taking system testing seriously enough, we have twice now sent a device that failed in the first week. I don't know how this happens. It just happens. We are taking it quite seriously right now. So all the prediction modeling, all the calculations, scientific stuff, simulations, or good engineering, seeking for advice will help a lot. So it's a crucial part. So not to just make mistakes with the shipping of the devices that don't work. We have the device that was working for 3 months inside of the lab correctly, perfectly. We shipped it, first week failed because in the shipping they moved it wrong, right? It was crazy. Feature creep a lot. Yes, it's very easy for hardware startups, and I don't suggest anyone to do so. Is to feature creep, meaning that when you propose your technology for a client, he will usually say, can it also do X? And don't try to implement this X in your device every time that you are asked for it, right? If you do, you will get the device that has many different features, and it's very sad for you to fail a device just because a feature that was not requested by this particular client failed, right? So you don't do that. Just have a strategy, work if it try to do it. If it doesn't work, just scrap the strategy, change it. Yeah, the team, 3 people, myself as a chief operating officer of the company. I also am responsible for the scientific part of the whole operation. Git Rozolinch, a wizard with the emails. So he sends 150 emails per day easy. He books, he looks at my calendar, decides where I have free time, books a meeting with some person, briefs me before it, collects all the different contacts. He has a CRM. Does anyone know what CRM is? Yes. He has a whole system just for the emails. He has like the lists of contacts and everything else just to follow through with everyone. And Gatis Tunans, extremely smart guy, extremely antisocial guy. So he will never do a presentation about the whole thing, but he can write you, he can deploy an SQL, fully deployed SQL database like in one day, if you want to do it. Crazy smart guy, huge respect to him, but you have to have the whole selection of those people, right? Yeah, thank you very much. This is the Tech, and we are always open to collaborate in the Horizon Europe or any other project as the Institute. I'm still affiliated with the Institute. I work half my time there, and with more investment, I guess we'll transition to a bit more, but I don't think that I will ever leave science in my life. Thus, if you want to submit Horizon Europe project with us, if you want microscopy data or some crazy scientific setup that we have at the Institute, feel free to reach out. And also feel free to reach out if you want to submit some project with the SME. So the Spectrum Marine is SME in the Netherlands, which can also provide quite a bit of value submission of a project. Thank you.
Makes sense, but maybe colleagues, if you do something to know.
No, just a comment that I really support your strategy, and that's what I also said as from the business perspective, that you must always build those support systems or ecosystems around you to validate your ideas, and that is the key to success. Otherwise, you're alone in all that pool of various ideas. But if you have strong partners by your side, you're able to push that forward.
Absolutely, the validation from the companies is huge. If it's very hard to grasp as a scientist, because you usually assume that if they say no, that you haven't explained something right, or they didn't understand something, but they did understand. They just don't want it, right? Or want it. I don't know.
So building up on Paul's how do you see like a Latvian or Baltic ecosystem helping you, or rather than discouraging your advancement? You went to so the area of that. Would you be able to build it successful also here? What is missing?
We built it here. Yeah. So this is the point. Like I think that the Latvia and Baltics in general, with different varying success, is a great place to build something like this. Just because of a single fact that since we are not a lot of people, we help each other quite a bit. And from my experience with building business in Germany, for example, in Germany, if you want to build a business, it has to be a business. For us, you have much more leeway to make mistakes or get results. For example, if it's also in science, it's just the same. In business, it's quite a bit different, but in science, the same story. But if I want to, for example, acquire a SEM image of a very particular material that I want to employ in the device, in Germany, I will absolutely have to pay a lot of money for it and wait for a couple of weeks. Here, I know a guy that knows a guy that can get my sample inside of the microscope today, right? It's just an extreme case of it, but for any other operation, I haven't seen anyone that looked at the spectrum marine and said, all right, I can help you, but I won't. Everyone helped whatever they can. So this is also the BioFOD program is huge for that. Absolutely apply for the BioFOD calls. It's crazy. You get money just to develop things that you can sell later on. For other countries, it's not the case. So it is built in Latvia, but it has to transition to the Netherlands to move forward because of the it's not a development anymore; it's a business, right? And if you are an investor and you see a water tech startup, you assume it's from the Netherlands, and if it's not, then it's a red flag, right? But we are still here. Right, we have a obligation to move operations to the Netherlands, business operations to the Netherlands, but the development will stay here for quite a bit.
Actually, a question about Baltic market in this case, or Baltic countries users. Are who interested in your product? And maybe another question: product is sensor or data and data related things? Because as I understand, you create a sensor. Are you sending sensor to client and with full access to data, or you process data yourself and help with data management?
I've heard three questions. First question about data. We do sell a sensor as a sensor, but for the whole idea of recommending that it's a system. So it's not only the sensor. In fact, from the development, like the development of the device of the system, only 40% is the hardware and 60% of the database and data analysis and everything else in software. Thus, we have a business strategy where we sell the device and you can access the raw data from it. And some basic analysis can be performed on the device. But if you want some advanced data analysis, you will have to pay subscription fee because you will use our video cards for that and servers, right? So this is the first idea, the first question. Second question, Baltics there are not a lot of clients that use water as a crucial part of the business. So there are not a lot of fish industry there. We have some on the rivers with the salmon and everything. But there is no business client that can facilitate the goals of us, right? We in Baltics, we focus on public funding and projects where we can apply the device to get data for public use. And the Interreg project is one of the examples where we will produce these 6 devices on 6 buoys in 3 different lakes in Latvia, Lithuania, in the border side. And get data completely free to everyone that needs it for the researchers. This is the main idea for the Baltics, and this because the Baltics doesn't fit in the whole structure of the value proposition for the business. And third question, can you remind me, please?
So data and Baltics, I think it's fine. And actually, I'll answer.
All right. So yeah, sorry.
One question about issues with patenting, and so you have a company and university institute. Patents belong to institute, but business doing by company. So how you divide or negotiate or questions related to patent?
Yeah, excellent question. I think that for the scientific person, it's a quite a different process than is expected for the company. But the thing is that if you create something in the institute or the Ventspils South School, I guess, everything that is created here belongs to this place, right? Exactly. So if it's created by public funding, it should belong to the public. And if you want to commercialize something and get value from it or get investment, this is a crucial part for the investment to get the patent to the company. So they will not give you an investment if it's based on the patent that belongs to someone else, right? So there is a patent transfer procedure that you have to follow if you want to buy something from the public university, and it's very much the same as the public procurement procedures. So you just go through the open market, and you get the procurement procedure from the institute to everyone else that needs it, and everyone has to compete for the better price. and Spectrum Marine just competed for the better price and paid for the patent.
Yeah, this is correct. Yeah. Thanks a lot. I think we have a bit lot of time.
I'm sorry about that.
Very nice talk, and I think we can continue in coffee break.
Sure.
Yeah, so I have to switch to my talk. Wait a second.
Oh, thank you very
Thank
much.
you, President. So
Thank you.
thank you for your participation.
Thank you for the invitation.
Yes, and we can continue later. Thank you. Yeah, so we have 10 minutes left until break, so I try to show my presentation as fast as possible. Not to make it long. And topic is mostly for modeling, but it's again. Yeah, thanks a lot. So yes, yeah, stop. Yes, screen was shared from another computer. Yeah. Now it should be fine. Yeah, thanks a lot. I actually continued topic about trying to make some kind of product and showing how you can use modeling things. So it's like a both in one presentation, and starting about some discussion about permanent magnet generators and components of them. So we actually use a lot of permanent magnets in our life, and
Jā, mums nobruka kompjūters, šitais dators restartēs. Varat nākt to zoomu ielikt iekšā? Zoomu paliec šeit. Yeah. Sorry, we have some technical problems with computer. It just died and I switched to another one. And we need a couple seconds to rejoin Zoom. Okay, So I will start presenting from my computer, but yeah, microphone will be working here. Okay, so
recording in progress.
okay, so I can continue with this computer as well. Okay, so I'm back. Sorry for some technical issues, and I hope you hear me and see me as well. Yes, on place participants are seeing me. Yeah, so I hope should work. Yes, so I will start. Permanent magnets are very usual and useful things in our life, and we try to make some kind of versions of these permanent magnets, and usually or permanent magnets, permanent magnet generators, and normally it's stator and rotor. So rotor rotating, we have conductors and magnets and coils and generating electricity, but it's like one of standard ways what we are working and seeing. In life, there is some kind of linear permanent magnet generators, which located in a linear way, and stator, the stationary part, just connected to, let's say, basement, and translator or alternator going one in another directions and producing same electricity, but not exactly rotating. And these enormous ways of using these generators, normal one, like a rotational and linear one. So it's like a wind turbines, hydropower, like a small hydro systems, any electric vehicle. So we now almost all electric vehicle has a generator itself. A lot of portable generators providing reliable power source, outdoor activities, construction sites, emergency backup powers, and so on. Same also maritime applications to generate electricity from wave or tidal energy. And this exactly case what could be interested for our solution. So in this case, linear generators, let's say for tidal use like a effects of moving waves, and here is some stationary part and rotor, which is just going in linear direction and producing electricity. In our project, we focusing on linear generator models, but a bit different way for bicycle generators. So it's like a small power generator, but it could be also scaled for a bit different aspects. And main change between rotary, this type of generators, which are like a very usual and general type. This type of generator is quite easily could be modeled. So it's a symmetrical, and we can make like a full-scale modeling of a magnetic field distribution, or make slices and see symmetrical patterns everywhere. But in our case, and this is also become a kind of a prototype and pilot products with Friendina trademark, so environmentally friendly small power generator with rotor linear motion, and it's like a use concept of linear generator, but make it on a like a brakes of a bicycle. So it's like a standard brakes more or less, and it's added additional design with the generator itself, which could power bicycle electronics itself. So it's not very powerful system, because when we are driving on bike, we producing some several tens of watt maximum. So yeah, not very powerful creatures as a man itself. Historically, it started in 2009 with some prototypes making in lab, or again some student projects, and student projects become a more general ERDF projects, which brings us idea how we can do a modeling of linear generator, how we can create them, and how we can make some kind of prototypes and products. These technologies for linear generators, several iterations and versions, was patented in Latvia and European patents as well. And as Alexei told, Latvian projects mostly asked about deliverable as a patent, and we satisfy with our public money. And after that, it was made some series of prototypes, which we can try to test and find out like a bad and good things and features of it. But there is problem. So if we are trying to model a linear generator, it's more or less a case, so it's not very complicated. But in our case, our rotor is a disk, and magnets and generator itself, it's like a making arc. And this becomes a nightmare for modeling software because it's not symmetric, and actually all fields you need to reconstruct like a point by point. And some designs what we trying to think and trying to test. And again, each design asking to make all model and recalculate everything. And one more in our cases. And again, in like a 2D plot, it looks very simple. So we have magnetic fields like going around coils and magnets. But if you're going to try to model full design, we try several softwares and actually fail with good results which are compatible with prototypes. And after that, we found EMWorks program, which is a part of SolidWorks. So it's integrated in SolidWorks, and this becomes very easy. You don't need to use several software for modeling. Use SolidWorks for model as a structure, and same software for modeling electromagnetic forces and fields. But in this time, it was 2019, I think, this program just arrived, and it's so team who produced this software was from Canada. They tried to sell this product as well, and they produce like a free trials for at least month. You can just take it and use, and if you satisfy it, or you need to buy it. We take it this software for a couple, just for months, test our model, and find out that the EMWorks are crashing in our model. So our model become too complicated, and so we try to contact this company. I said, okay, sorry, we understand, so something goes wrong. Give us additional time for testing, improve their software, and send us additional versions. And in total, it takes like a 3 iterations for us to adjust our model and like a 3 versions of these software developers to make it software stably working. So I probably need to go to lunch, so I go very fast and show some results. So how it looks, so we have a standard SolidWorks design, and EMWorks defined magnetic fields density, and successfully make models and trying to do results. And these results are also later combined with physical samples that we have created and studied in laboratory, and got similar. So okay, I'm not stopping on a plot because it's quite timing to explain, but it works. And this probably nice story how we from researchers could also interact with software developers and improve our knowledge and improve products as well. And yeah, so I will just not stopping here. Finally, we got nice testing. It just won't stop. It's not our generator installed, but it was tested in errant race bicycles from our Latvian company. So, and again, we are trying now to find some users and probably to establish something what Alexei says like a startup and then continue with the development of business models and products itself, because currently it's around TRL 6, 7. So we normally test it in laboratory, have pilot products or pilot versions, and at this moment it's stopped. Okay, so I think I just stop my presentation here because it's too time to close this session. If you have any questions, or we can discuss it in lunchtime. Okay, so now we have lunch until 1 o'clock, and so I will. So yeah. So we will join our session next at 1 o'clock, and I'm share screen and left screen sharing as well. With continued presentations with our colleagues from Latvian University and Riga Technical University, but they are mostly online. So 2 presentations about like success stories about projects, and 2 presentations by Modris Dobelis about practices about in SolidWorks and some features what we can do in SolidWorks. Yeah, so thank you, and time for lunch. Tija, vai tu esi šeit?
Jā, sveiki, es esmu šeit.
Sveika. Jā, varbūt es tev iedošu tad sharing un var mēģināt slēpties. Nu, tā kā laicīgi vienos tad sāksim, tad jā.
Tas. Tā. Aha. Vai manu prezentāciju var redzēt?
Redzam prezentāciju, dzirdam arī diezgan skaļi forši.
Ļoti labi, un prezentācija iet uz priekšu.
Prezentācija iet uz priekšu.
Nu,
Jā, seju tev pagaidām neredzam, bet vieta ir. Tā kā kameru.
Tūlīt ieslēgšu.
Forši, tad mēs tevi arī forši redzam. Jā. Labi, tad viss kārtībā, tad vienos sāksim, tad jā.
Ok, ļoti labi.
Labi, pagaidām tad es tāds ekrānu droši vien varam atstāt, bet tad video skaņu pagaidām izslēgšu, jā. Hello again. So we continue our workshop, and the next session, first speaker will be Tia Sija from University of Latvia. So Tia, you are here. We see you, and yeah, please start your presentation.
Yes, hello. My name is Tia Sija. I'm from University of Latvia, from Faculty of Science and Technology. I apologize, I'm a bit sick today, but I hope that will not make my presentation much worse. So the topic of my presentation is how to determine wind speed without measuring it. Of course, the topic is about wind energy, but when I was creating this presentation, I actually answered this question in presentation, but it's pretty far towards the end. So we will get to that question, but before that, we need to start with some introduction. So, why do we need wind energy at all? Because I will start by assumption that renewable energy is good. There can be many different opinions, but I don't think that this is the time and the place to discuss them. So let's assume that renewable energy is good. The thing is that solar energy is much cheaper and easier to install from a regulatory perspective. What has happened with solar energy is that the cost of solar energy, it has decreased rapidly, exponentially. It's, if you know the Moore's law for computers, then it follows the Moore's law, the price of solar energy. Why do we need it? Why do we need wind energy at all? The thing is that we still do not know how to accumulate energy easily on industrial scales, on scales that is relevant for the wind grid. And the solar has quite significant limitations in this regard, as we regrettably know here in Latvia. During the winter, the sun is a rare occurrence, and it's typically about 1 hour of sunlight per day, if that. And of course, there is no sun during the night. So we need something else. We need wind energy. That is the opposite of solar in terms of when it is generated. We of course know that the solar has a diurnal and seasonal cycle. Maybe the lesser known fact is that the wind also has both diurnal and seasonal cycle. And what we can see here is that in the graph, it's the energy generated in 2023, and here are only two of the sources. The orange is solar and the green is wind, and you can see that, of course, obviously there is much more solar being produced during the summer, but for the wind the relationship is opposite. We have a lot of wind during the winter, and it is during the winter, the wind has almost no diurnal cycle. The wind blows almost the same for the whole day and night. But we have this seasonal cycle, and we see that we can complement the solar energy with wind energy. There is one more thing that you need to know about the electricity market, because it's quite easy to, relatively easy, to put on a solar panel. You just buy on this increasingly cheap solar panel. You have a green field with some grass and maybe some sheep on it, and you just install the solar panel in roughly the direction of south, and and you can generate energy. And this seemed like a good idea, therefore a lot of people did it. And now is the situation that when there is a lot of sun in Latvia, then the electricity price is negative because everybody is producing it. So there is a strong economic incentive to generate energy when there is no solar energy. Now, okay, let's assume that we are in agreement that we need some wind energy. The next problem is that the wind turbines are quite high. There are a lot of problems that come together with it, but I will focus on one of them. And the typical height of wind turbine is around 100 meters. I think it's not very surprising that we need to know quite precisely what is the wind speed at 100-meter height. And because the process is so complicated, the wind developers, they need to know the precise wind speed with precision of 5% would be ideal. It's not like in other engineering disciplines where we can just make some safety allowances. The wind needs to be known very, very precisely. And this is very important at the wind turbine height, which is 100 meters. You might think that well, where is the problem? We have a lot of information about wind speed. The forecast is I can open my phone and see the wind speed forecast. However, that is the thing that is assumed by default and therefore usually not said out loud. I would say every normal wind speed forecast or wind direction forecast that you see, it corresponds to 10-meter height. It's just by default. You might know that there are lots of wind measurement stations, meteorological stations, around 20 in for whole Latvia, operated by our Environmental Geological Meteorological Center. However, they all measure wind speed at roughly 10-meter height. The problem is that wind speed at 100-meter height differs significantly from the wind speed at 10-meter height. Usually, in most situations, the wind speed will be higher at 100 meters than it is at 10 meters. However, I would like to the thing that I would like to stress is that what you see in this graph is that on the x-axis it's wind speed and on the z-axis it's height from the ground. So these are some typical wind speed profiles that we can see. And the important part is that the relationship between the wind speed at higher heights, at the turbine heights, with the relationship of wind speed at 10 meters, there is no one single relationship. If you have measured 10-meter wind speed, you cannot reasonably calculate the wind speed at higher heights at 100 meters because the relationship from physical because of physical considerations, it depends on most of all the land use. It will be different between sea or some kind of urban area, and it also depends on the meteorological conditions. So this difference is governed not only by the surface, but also by the by weather, the amount of sun, the amount of wind speed. So the one conclusion that I would like to for you to take is that if we want to build a wind turbine, we must measure wind at every location where wind turbine is planned, and we must measure it at 100-meter height. That's non-negotiable. You can't calculate your way out of the 10-meter wind measurements. So how can we measure wind? There are two main approaches. One is this cup anemometer, technologically quite simple. The wind blows, these cups go around, and you can determine wind speed. However, again, remember, we must measure it at 100-meter height. So it needs a tower to be put on. And I assume that it's not hard to guess that building such a tower offshore is quite expensive because you literally need to build tower in the middle of the sea. There is other approach. You can measure wind speed at quite high at turbine heights from a wind lidar that's put on the ground. It's a remote sensing approach. It gives quite reasonable results, and you don't have to build this tower. You can do it from the ground. However, as we can see, it's not cheap. So, and there are some additional problems. You can't measure wind speed for a day or a week or a month and say, okay, I have established my wind speed. Climatically, it would be good to measure at least 10, 20 years. The definition of climate is the 30-year average, but of course no one has time to do that. But you should try to measure at least 1 year because of the seasonal cycle. And of course, we know that we have hot years and cold years. For instance, we have a very cold summer, a very cold winter right now. We also have windy years and still years. There is some variation between the years. And what we cannot do, we cannot travel in time and say, oh, this is our location. I would like to measure wind starting from 10 years ago. You just can't do that. So the wind measurement is necessary. However, we need to at least supplement it with something else. And then our wonderful solution is numerical or mathematical modeling. And I will be talking about it for the next slides. So first of all, the numerical modeling or mathematical modeling, it's not scary. It shouldn't be scary. I promise you that you have used products of numerical modeling every day. That's your average. That's your average weather forecast. I would say that all weather forecasts that are not based on the question, you know, you can look at your cat and say that if your cat is becoming fluffier, then it will be cold winter. Those are not those forecasts are not based on numerical weather prediction models, but the rest, I can guarantee you, there has been a model that runs to create this forecast. So what is a numerical model? The simplest way how I can ask you to think about it is that it's a computer program. That's what it is in essence. However, it's a very specific computer program that implements physics equations. Namely, we have found a way, it's quite an old approach, how we can implement physics equations, the laws of physics, in a computer program. And typically, the result of a numerical model is, you can think about as a spreadsheet full of numbers. But these numbers correspond to the values of physical parameters. And typically what we do is we visualize it as a plot or as a map, in most often the case of wind energy. Vladislavs informed me that this will be quite a general audience. So I was thinking, what is the best way how I can explain to you what a numerical model is? And if you are unfamiliar with numerical modeling, I would recommend to think about it as a very precise video game. There are some commonalities that can make you understand numerical models better. And of course, there is also a very interesting thing that you might know, that video cards or graphical processors, they're nowadays very much used in AI, and the video cards and GPUs, they started as something for video games, and the underlying mathematics is quite similar, so it makes sense. And we know that and that computer programs, they need to know laws of physics to look natural. They are quite tricky to program, and there are two more aspects that I would like to stress. Is that you need that if you want to run a really nice computer game, you need a powerful, really powerful computer, and that is very true about numerical weather forecasts. And another thing is that you need the program to work quickly. You need to generate the results quickly. There is no point of video game if you get 1 frame per minute. The same is true for numerical weather prediction models. And I will not attempt to explain the full meaning of computer models. There are university courses for that. But there are two things that you need to know about models that I will try to explain to you in a simple way to understand how this wind resource estimation works with models. So the first of all is that this is different from a computer game, that models calculate the evolution of the state of atmosphere over time. And we are simulating a specific time and specific location. Our calculations are, they correspond to a specific time and place. And the other thing is that all models have a property called resolution that determines how precise the model results are. I will go into detail in those aspects over the next slides. So what you have to understand is that models calculate how the state of atmosphere evolves over time. Again, if you would like a more simplified example, we can, let's say we throw a ball in the air. We know the position and the velocity of the ball, and using the laws of physics, we can calculate how the ball will move afterwards. It's the same with weather models. We can we determine the state of atmosphere at a specific time and area, and we use these models to evolve how the atmosphere will change, how a cyclone will come towards us, and how it will start to rain. And what is interesting now, we have to separate two different things. One is these forecasts that are on your phone. They correspond to time in the future. The calculation is made so quickly that the forecast is ready before the time has happened. However, what we can do, and what is most important for this wind resources estimation, is that we can run the model for a period in the past. We can make the model represent atmosphere in the past. That's one thing. And the other thing is this resolution. Again, very simply put, we divide the atmosphere in very small pieces, both horizontally and vertically. It's called grid. And almost the general rule is that the smaller the piece, the more precise are the calculations. Again, there's a good explanation why it is the case, but I will not go into the details. And we call this the typical size of the piece, we call resolution. And the typical resolution of numerical weather prediction models are between 3 and 30 kilometers. So now I will be answering the question that I posed at the beginning, how to determine the wind without measuring it. So the thing that is being done by a lot of people is that you run this numerical weather prediction model, you run this computer program, but you put the data in such a way that the state of the atmosphere corresponds to 20 to 30 years in the past for a region of interest. And that's another limitation. Let's say you are interested in a single point However, the models, you cannot run the model for a single point. It doesn't work that way. Let's say we assume that Latvia is a 500 times 500 kilometers. You need much larger area, at least in the thousands. It's easy to understand if you listen to the weather forecasts and you know that there is an anti-cyclone over Russia determining the weather today, or there is a cyclone coming from the west. Regrettably, the whole atmosphere is joined together in processes. And again, getting back to the analogy with computer games, it is computationally very, very, very expensive, and therefore there are only a few institutions that can do that. There are two main types of datasets. That's why I invoke this property of the model called resolution. We have, for example, Era 5 that covers the whole globe, and it provides wind speed data with 30-kilometer horizontal resolution. However, because of the huge interest from industry in this topic, there are wind atlases with much lower resolutions. For instance, the New European Wind Atlas that I participated in creating it, so I know a bit about it, and it covers only the area of Europe, but it provides much better horizontal resolution. I can go on and on about why smaller resolution is better, but I want to just point out a few things. A lot of this data is available completely free of charge. And I would like to stress that modeling data is available free of charge. You can just go to one website or another and just download it. And there are also some private companies that are offering proprietary modeling data for a fee, but you almost cannot get high mass these 100-meter wind observations. They are mostly done by private companies, and they are secret. It's a secret information. You cannot get it. However, these free of charge datasets, they can be very large, up to terabytes. And they need to be geo-referenced. They need to have a lot of metadata. So you probably, most likely, won't be able to just download an Excel file. You will need some kind of Python. The data will probably come in specific formats. They're not very hard to work with. They're actually quite reasonable. If you know Python programming, it's reasonably easy to do, but you won't get this data in the normal formats like Excel. And the last point I would like to make: why offshore wind? Offshore wind has obviously its drawbacks, mostly associated with the installation costs. However, in Latvia, a simple thing is true, and it holds true quite, almost all situations, is that for Latvian climate, not for Southern Europe, for Latvian climate, there is significantly more wind over the sea. This is actually a result of one of these wind atlases that I mentioned earlier. This is the wind power potential over Latvia. Here you can see this color scale. Here, not a lot of wind power. Here, lots of wind power. So it's quite easy. There is, of course, a simple explanation for that. You can think about the wind speed as coming mostly from the west. You have large wind speeds over the ocean, over the North Sea. The wind rubs, and the wind loses its velocity over the land. So we have Scandinavia, a bit where the wind loses its wind speed actually quite a lot. And over the Baltic Sea, the wind is already smaller, and then the wind speed slows even more over the Kurzem. So over the Gulf of Riga, the wind is even slower. That's roughly the case. So I would like to leave some time for questions. So these are just the conclusions that for wind energy, we need to know wind climate at 100 meter height with quite a lot of precision. We can, of course, measure things, but measurements are expensive and they take a long time. So the alternative is that we can use complicated computer programs to establish historical data speeds. They are, of course, not perfect. You need to compare them with observations, but it has been done for Europe and Latvia. Therefore, I would, if you are interested in this, I would recommend that you start your investigations in this area with those ready-made data sets. So that's all from me. I hope that there will be some questions.
Thank you. Now, I don't know if any questions here. I see no hands, no responses, and yeah, so no questions from online speakers and listeners as well. It looks very nice, and I recognize Neva map from your last slides. Yes, it's maybe not outdated, but it's not new anymore. So it's like 3 years, 4 years ago, but still maybe recent Baltic Sea resource for wind source. It's like a wind models. And maybe you know about some kind of newest versions or something like this.
The thing is about wind climate that actually, if for temperature and for the number of days with snow, there is quite a significant impact of climate change. Actually, for wind, the impact of climate change is much less pronounced. So the fact that we have older data for older periods of time, it's not as bad as yeah. And the previous European wind atlas, I think, is from the 90s. So there's quite a big gap between these wind atlases. They won't be.
Yeah, it's for more than 20 years, I think. So
Yeah, there is one reanalysis called NORA that it's newer and it's quite good, but it covers I think Latvia a bit. It's mostly focused on the Scandinavia. So there are smaller, more focused products that you can look into, but it strongly depends on the area that you're interested in.
But do you have experience with Copernicus Wind Atlas? So as I understand, it's based on satellite data. So it looks quite new as well, but I have not deeply go inside. So just find it's nice data, but not able to compare it with Neva, for example.
I will have to look into that. What I can say that from satellite, first of all, from satellite you can measure the wind speed only over the waters. And also there is this problem that I already talked about, that when you are using satellite, you are measuring wind speed over the water by measuring the properties of the small waves on top of the on top of the water. So by definition, you are measuring wind quite close to the surface of the water. And again, if you want to calculate the wind at 100 meters, then you have to be very, very smart about it. That's the thing.
Yeah, thank you. Yeah, I think so. All questions from my side. Thank you for joining us and thank you for your talk.
Thank you.
So, Andres, are you here?
Yes, I'm here, so I can share my presentation.
Excellent. So, yes, please share your screen. And Andres Zvaigzne, Riga Technical University, with his talk, Coastal Fishing Vessels Powered by Zero Emission Hydrogen Fuel Cell. Yeah, so we see your screen, but not full screen.
Okay, just a moment. Oh, it's better now?
Perfect. Okay, so yeah, floor is yours. Let's start.
Okay, thank you very much. I think also my presentation is a very good fit for the TIA presentation. Yes, first of all, I'm Andres Weiss, I represent Riga Technical University, and I will talk about our new project, what we are doing, this Horizon project, how to seize. And as I tell, it's perfectly fit for the previous presentation. As we learned that there is some periodical in energy, so we can some periods we can have more sun, when sometimes we can have more wind. But the question how to store this energy and what to do it, and one of the solution, of course, is hydrogen. That hydrogen can be used for store the energy and use it when it needed, but not when you have a sun or when you have a wind. So our project is a cost-efficient vessel powered by zero-emission hydrogen fuel cell. It's under the Horizon program, and the idea is to build a vessel, efficient vessel, using this zero emission and mostly using this hydrogen energy to power this vessel. Oops, sorry. In simple word, what we want to do, we want to design, build, and test real fishing vessel, 12 meters size, what can be operated in Northern Sea and the Baltic Sea basin. Project partner, it's Riga Technical University lead partner. We have also Stockholm Environment Institute, French company Genevas, responsible for the hydrogen part. Atos Group is a shipbuilder, and Vidzemes University of Applied Science for our legal and testing. Standard working package what we have in the project. VP1 is the overall management. VP2 is we evaluated regulatory aspect and marine environment impact using of the hydrogen and how its impact was a law regulation, etc., etc. VP3 is a zero emission solution. It's a hydrogen system itself, how it's installed and how it's modulated and for the vessel. Shipbuilding, of course, it's everything that's related to the ship construction. VP5 demonstration at sea, and VP6 is a dissemination exploration. Take into account the direction of our seminar, so I will focusing on this two working packages, what is more like say hard part of the project. It's a zero emission solution and shipbuilding. A few words about the hydrogen technology. So this is a alternative to the thermic power engine, and it's of course have several advantages. First of all, there is no emission of the use of this technology. There is no noise. There is no smell. It's very reliable. There is no too many moving parts. It's of course very efficient. If we compare with a fuel cell, where is this maximum 35, 40 maybe percent in the best case. In case of hydrogen, we can use up to 80% of efficiency. It's a scalable, so it's easy scalable. So we can put the small models and have a bigger effect, and can use several fuels: hydrogen, natural gas, LNG, LPG, several. So for Genevos, our main partner is a French company. They produce the hydrogen powered fuel cells systems, what's specially thinking and specially built for marine application. And in our project, they create this hydrogen system, storage supply specification, manufacturing of hydrogen power model and pre-assemble this model for the installations of the vessel, on the vessel. General idea of fuel cell, that hydrogen coming together with oxygen and produces electricity, what we can use later on for different purposes. We will have this a hydrogen-powered model 40. These two models will be installed on our vessels. There's a general idea that it takes this hydrogen, it uses air from outside, and what we have, it's water, hot water, electricity, but also what we need to cooling using the seawater for the cooling of the system. Powered model, it's a little bit scheme from the inside, that it's we filtering the air. Let's go in the model. Also, it's a gas management system. And what we have on the tents, it's electricity and seawater, fresh water, and other stuff. In the principle, what we have is two balloons where we will store the gas supply, power models, and let's go for the producer electricity. To calculate how much power we need, we also for the ship design, we make a typical fisherman, the coastal fisherman activities. How much power we need to leave harbor, transition to the fishing area, stay in fish area, and coming back. So we calculate approximately how much power we need for this. Build a graph. You see here, it's we use energy from the power fuel cells, hydrogen, and also the electric battery. So the idea is that to the end of our storage of hydrogen is almost empty, but on the end of the trip, our electricity is almost full. So it's how it's look on the vessel. There's two bottles, go to the fuel cell, go to the electric battery, electric motor, and to the propeller. The main components, as I mentioned, this is a storage, this is electrical cabinet to control, the valve panel to control the gas flow, and the safety different sensors to control the situation of the vessels. So this is a principal electrical. And the valve, scheme. Problem also, the disadvantage of the hydrogen, of course, is a big storage compartment, what you need to keep hydrogen on the vessel. So we will use a special marinized system, the Luxfer gas cylinders. And this is an electrical system, the control system where we control the bunkering station, we control on the bridge, we control the general sanitation and energy management system for the vessel. This is also some advantage and disadvantage of the fuel system and putting on the deck. So we have a better stability, but of course less space on the deck. Easy to control attic zone. Well, I explained later on. Yes, so putting the batteries over there, we easy to control. Attic is a dangerous zone for the exhausting gases. So in case of any emergencies, this gas just go up and not affect any deck space area where the personnel waiting and walking. This is manufacturing of these models. This you can see is a testing before they deliver it to the vessel. They make a rolling pitching, so the system can work in the hard environment. This is the cylinders. As you see, it's quite big. It's almost 3 meters long and quite heavy, but it stole only 9 kilo of hydrogen each. So this is a valve panels what we will install. And for the shipbuilding, also you see one of disadvantage was the big storage compartments, these bottles. So we need to take care of it. But before we start, we define the prototype, what we need to build, how we need to build, what the operational cycles for the normal coastal fisherman boat. We make a feasible concept to make a preliminary design to see how to install this big bottles. You can make an imagine for the 12-meter boat to have 3-meter balloons. It's quite complicated using all the stabilities and calculations of the vessel. After the preliminary design, what we deliver it to the shipyard. Shipyard go to this for the construction design, and the problem also that what is very challenging for this project, that we want to deliver a sailing ready boat what they fully certify. So the readiness level of this project need to be almost the maximum. So this is normal vessels what we can sail at sea. So it's put us on the very hard requirement from the Latvian Maritime Administration. And as they have no experience of certify the hydrogen vessels, so they say that you need to go through the class certification, and we go to the Lloyd register, we go to this GNV, but finally we find this Polish Maritime Register who certify, so control the shipbuilding and certify the project. Here, also back to the topic of the seminar, this is some drawings, what technical drawings we did for the vessels. Yes, this is was quite challenging to select the classification society. Also, it took some times, and affect a project. But finally, we succeed, and we are on the process of a shipbuilding now. So this is some fundamentals for the construction. So we several steps for fabrication. This ship construction, general arrangement, selection, and the different system what need to be built, and first of all, of course, design and build inside on the vessel. So you can see some drawing, the technical drawing, what necessary for ship certification and also for the construction. The whole, the build and ventilation. As we use hydrogen, so it's a very complicated, I would say, ventilation system for the 12-meter boat. And we need to develop all this for the safety reason. Also, as we go into deliveries, show the ships in different place in Europe, so we make the removable wheelhouse, so a superstructure need to be connected. This in May we make the first welding. So you can see some pictures, the boat. As you see, the construction go upside down. So we make the main structure. And of course, all the construction is supervised by Polish Register of Shipping. So they make a several inspection. Oops, sorry. And finally, we turn the vessel, let's say, normal position. And our ambition is to make a demonstration at sea in June in Latvia, in August in Pärnu, and in September we want to bring this vessel to France, to Boulogne, to show there. So this is a main presentation. So thank you.
Thanks a lot. So very interesting. So you're almost done with production, and in next months, actually, you're starting testing it, right?
Not actually, not that. We just finished with a hull, but still a lot of work need to be done. All the inside installation, and hopefully in a few months we will bring all the hydrogen system from France to install on the vessel. So it's still a lot of need to be done for the project.
And what about like a filling with hydrogen? So are you planning to use some kind of existing infrastructure, which is, I understand, quite rare, or just bring hydrogen in
Thank
tubes?
you for the question. It's really headache. I am not current here because it's another working package. But yes, when we start this project few years ago, actually, yeah, you know how it is. You write it, you submit it, you wait for the result, and it was quite ambitious plan that we will have this hydrogen supply station in Riga and several stations around Latvia and in Estonia and France. And unfortunately, for the last years, all this project was put on hold or cancelled. So it's quite a challenge now. In Riga, for the moment, we have only one for the bus station supply, but it's not really convenience to bring vessel to the bus station. So there is in Jelgava now also for the bus, and they have some sort of mobile station. So we are looking now. There is also a big international company who can supply this, and it's generally it's possible. We discuss with them; they can do it, but we are still looking for the better and cheaper options, because also one thing that we need to bring the supplier to the vessel. That means that it need to go to be movable, and they need to go to the vessel. And another, it's also need to be certified, because the gas need to be clear enough that there is not cost a problem for the vessel at sea.
Oh, thanks a lot. I think it's a question to market project as well, because we are trying to identify problems and gaps in innovations and infrastructure in the Baltic Seas. And this is clearly one of the problems what we need to highlight about refueling stations in port and services regarding hydrogen. So you are having ships with good work and could be replicated, but not infrastructure not ready for these ships at this moment. So it's a problem. Thanks a lot, and thank you for coming to our workshop and with a very nice presentation. Good luck with your project, and we try to be in contact and follow your results as well. Thank you. Any questions?
Thank you.
No questions. Wait a second. Looking for it.
Thank you, and good luck with the seminar.
Yeah, thank you. So no questions. So we can continue to another talk. Yeah, so now we have a bit another format. So now before it was talks, just the discussions and showing cases of real results. But next we will try to switch back in demonstration modes. And Modris Doboris, are you here? We see your screen, but we don't hear you.
Okay, good afternoon.
Good afternoon. Nice to see you again. Yeah, so I will give floor to you, and as I think you will show kinds of demonstrations how we can go back to SolidWorks and use this tool for modeling as well. So yes, floor is yours, and we can start. And I switch myself.
Okay. Too many screens to manage. Sorry. My name is Modris Doblis, and I am from Riga Technical University. In this lecture, we will move from educational framework I talked yesterday to applied examples. However, no water, no wind, no so global simulations that I had before in your workshop. Sorry, down to earth. In modern engineering practice, digital simulation has become an essential part of the design workflow. For many students, CAD feels intuitive because it is visual and immediate. Let me start with a few case studies of typical simulation tasks inspired by local industry. As I mentioned yesterday, some of them joined my courses, regardless that they are specialists in their field better than me. At the end, I will conclude with a structured parametric CFD workflow. The focus will be on workflow rather than on the physics, what is beyond the scope of my courses, as I mentioned yesterday. The scope is how a simulation task is defined, how parameters are selected, and how parameter what-if scenarios are set up to support engineering decisions. My introductory course is SolidWorks, and it focuses primarily on creating parametric design intent-based geometric models suitable for simulation and later reuse in what-if scenario studies. A secondary goal of the course was to train students to independently identify simulation tasks in selected reverse engineering projects, especially those that would benefit from high-performance computing resources, and to gain initial hands-on experience with these workflows. The course does not cover simulation physics, as that is the responsibility of later, more specialized courses. This focus was also a practical requirement to secure additional funding for the development of teaching materials in this project, the results of which are partially shown in my presentations. Oh, sorry. For this reason, I recommend sorry, I lost the slides. For this reason, I recommend exploring the flow and thermal simulation examples, as they clearly demonstrate the values of parametric models and fit naturally into more complex CFD and multiphysics studies. Using SolidWorks, a virtual 3D model of the device is created, which is then analyzed with flow simulation to study gas or liquid flow and thermal effects. The correctly performed simulation, users must understand the physics represented by the model. This requires clear control over fundamental geometric entities: points, lines, planes, surfaces, and volumes. Based on the simulation results, the model is iteratively modified according to the defined design intent, and simulations are repeated until the satisfactory performance is achieved. Only after this virtual validation step is the physical prototype manufactured. Without the correct geometric and physical understanding, even advanced simulation tools produce misleading results. Beginners often confuse 2D geometry with 3D bodies. Example, hexagon in plane, 2D plane, versus cylinder in space. That is true for this today's students, which leads to invalid simulation setups. And as a consequence, it leads to the famous quote, garbage in, garbage out. So you get nice pictures, but they are useless. Before focusing on the Tesla valve, I would like to briefly show several applied digital simulation examples. These were prepared by participants of my course from industry and by students based on their own real engineering tasks, demonstrating how simulation is used in everyday professional work. Here you can see airflow simulation in a hot swap fan. Here, CFD is used to analyze cooling efficiency and flow distribution under constrained installation conditions. Familiar company in Latvia. Some of you might know, but I will not just name it. In a chemical reactor, parametric simulation allows studying how diffusion is influenced by factors such as reactant concentration, temperature, reactor geometry, pressure, diffusion coefficient, flow regime, and fluid type, which is critically important for understanding and quantifying mass transfer in industrial scale chemical process design, because improved diffusion leads to better reactant mixing, more complete chemical reactions, and ultimately a more economically efficient process. Next, natural convection in a unipolar stepper motor drive. A thermal fluid interaction example illustrating how buoyancy driven airflow affects heat dissipation without forced cooling. Further studies for the stepper motor are expected to increase model fidelity toward the real prototype by introducing more realistic part-to-part contact definitions, modeling forced airflow with improved aerodynamics accuracy, and using thermal simulation results to optimize heat sink, size, and placement for a given airflow, as well as fan parameters under fixed constraints of the drive prototype geometry. Further studies in this case, the student demonstrated how a complex engineering system, a turbojet engine, can be analyzed using parametric modeling and CFD within SolidWorks. A detailed 3D model consisting of 761 components was created using a top-down design approach and then used for an internal flow simulation representing high-altitude takeoff conditions. The simulation visualizes airflow path, pressure, and temperature distribution, and velocity changes inside the engine, showing how air moves and interacts with internal surfaces. The results illustrate stable pressure levels and predictable temperature increase due to thermal loading and realistic three-dimensional flow behavior. Overall, this example highlights how parametric CAD models combined with CFD can be used not only for analysis, but also as an effective tool for understanding system behavior and supporting design decisions. It is important to note that SolidWorks flow simulation is intended for low speed and moderate compressible flows and is not suitable for high Mach number regimes. Applications involving strong shock waves or hypersonic conditions, such as Mach 5, require specialized CFD solvers. Tesla valve, in my example, is used as a convenient geometric example to demonstrate a what-if CFD workflow, including scenarios that may benefit from HPC resources. At this stage, the emphasis is on parameter control and the result interpretation. Detailed fluid physics is intentionally left off for online self-study or later courses. For context, the Tesla valve principle is widely applied in microfluidic devices such as micropumps and microvalves, where it enables directional flow control without moving parts, which is especially valuable at small scales. Further, I will briefly introduce the geometric parameters used in this study. My practical sample focuses on how to properly set up a parametric flow simulation in geometric model rather than underlying flow physics. But before this, I would like to reflect on what I saw and heard yesterday about the Service Pack 1 of SolidWorks 2026 coming up next Monday. In fact, SolidWorks, the announced artificial intelligence also has for a long time built in, which is coming up only. The result of preview we all saw yesterday, and but however, the industry will not yet be very happy with this. Here is the example of what my students do with this standard view one button setup, which is similar like this artificial intelligence. We must be careful with not overestimating the current power of artificial intelligence. So this is one button drawing the students prepare, but I expect something like this. So a small off topic, but still connected with SolidWorks. So PLM-oriented CAD training of Gen Alpha at the universities is an enormous challenge today. So especially when the baby boomers generation like me has to teach them. So back to Tesla valve. In this CFD study, the Tesla valve model is evaluated within a defined parameter range by varying the numerical value of a single geometric parameter in discrete steps. Even changing two parameters across a range rapidly increases the number of simulation variants, while three parameters, if you want to change, already require systematic planning of experimental points in a multi-dimensional space. When the number of parameters grows beyond two, classical manual experiment planning becomes impractical and must be replaced by dedicated experimental design methods. By the way, as early as 1977, Vilnis Eglais, a researcher from RTU, then Riga Polytechnic Institute, developed an original optimal design approach based on the theory of experimental planning, closely related to what is now widely known as Latin hypercube sampling. In this demonstration, HPC-assisted simulations were therefore limited to varying just a single one parameter. The angle beta in this drawing within the shown range from 45 degrees with increment 5 degrees until 100 degrees. The design in SolidWorks was created as design intent, which follows the design intent, and these all red parameters control the setup of this design. Here are shown some screenshots from this setup. Later we will try to practice by ourselves, but in much simpler case. So setups of and some steps of solution. I saw yesterday you were also practicing on one example which was very similar to this I'm going to show you today. The task in this project was to prepare simulations which require HPC resources. But to prepare this before they know this physics, therefore this was great challenge for beginners. The simulation task must be executed remotely on RTU supercomputer using standard Windows remote desktop connection. So actually the connection is very easy. Each project participant was provided with an individual remote access account, allowing them to work in a familiar desktop environment while using HPC resources. A dedicated SolidWorks virtual machine is configured on HPC system to match the specific requirements of the simulation tasks. The CFD model is first prepared on a regular personal computer, not so powerful, and then it is easy transferred to HPC virtual machine, where the SolidWorks flow simulation solver is launched. And if the computational load increases, the task becomes too complex. An additional HPC resources can be added in the same setup, and the task can be simply run, enabling larger or more detailed simulations without reconfiguring the primary virtual machine, which was assigned at the beginning for the participant. The following screenshots are shown primarily to illustrate the simulation setup workflow rather than to analyze the results itself. They highlight how the geometry, boundary conditions, parameter definitions, and solar settings are prepared in practice. At this stage, the goal is to demonstrate the structure and logic of the setup process, not to evaluate the physical correctness or optimize the design yet. In this presentation, I focused on explaining how to set up a parametric CFD study in a structured and repeatable way using SolidWorks workflow. The emphasis was placed on creating a clean parameter-driven geometric model, defining meaningful boundary conditions, and selecting a limited number of parameters to explore realistic what-if scenarios. By deliberately varying only one geometric parameter, the study illustrates how parametric simulations scale in complexity and why experimental planning methods and HPC resources become essential as the number of variables increases. The key message is that simulation value does not come from colorful plots, but from well-prepared model, controlled assumptions, and a clear understanding of what questions the simulation is meant to answer. Actually, this is, thank you for your patience. And actually, this is all for the first theoretical part I was going to deliver to you.
Thanks a lot. Quite interesting. Any questions or comments? Any questions from YouTube side? Okay, so I see no activity. Yeah, probably we can continue with second topic. And you made SolidWorks example. It's exactly about this practical with the Venturi tube. Is it right? Or so SolidWorks file what you sent it before. This is about this one. Yeah. Yes.
This is about what I prepared when you asked me some practical. I don't know it will fit your needs, and unfortunately the problem was I work with SolidWorks 2025. And files are not back compatible, and you are working in SolidWorks 2018. And yesterday I was able to find one old machine where I had SolidWorks 2017, where I, through step file, converted the current contemporary model to the old one, so you can open it without wasting time to build it from the scratch. And but a short time before I tried to check if the model works. Looks like it works, but might be some problems because of these versions. So each year, new version, new challenges for CAD designers. As you know, all you are familiar with this.
Yes, it's a problem. So it's new features, new looks, and you need to again learn how to use it. No, not from beginning, but it changes a lot, sometimes a lot. But I just in parallel try to run this part, and no, at least in our computer it's opened with no errors. So this is probably good. So I think we can listen your presentation, and after make a coffee break and relocate ourselves to computer class, because now we in auditorium, and continue like in more like interactive way in this case. So, but yes, but please continue.
Okay, are you ready?
I think, yeah, so I'll switching myself off.
Yeah, okay, I will try to slowly go on. So I'm sorry, I did.
Maybe yeah. Not, sorry, maybe now you can go like fastly through how it works, and after we in slow regime repeat it like a following your guidelines. Maybe we can do it like this one.
Oh, sorry, I expect that you those who want to participate are at least familiar with very basics of the SolidWorks, how it works. And here is represented a 3D model, part model of Venturi tube. Actually, after converting it, introduced some visual assistant planes, which I forgot to turn off, so we can start to improve a little bit this model before we proceed with simulation. So first of all, we can get rid of these plane 2, planes 3. Here in the design tree, they, after converting, are left as visible. If you show here with cursor and right-click on plane 2, several icons appear. We need to hide this one, not to represent. Not to bother us here. The same applies to the plane 3. We can get rid, hide it, it's there, but it's just does not bother us. The second model has not assigned material. To be transparent, to see the work, this flow inside, let's assign glass material. Glass material to assign in the design tree, we must use right-click, edit material, since we do not have glass here in the basic material list. So right-click, edit material, find under the non-metals, other non-metals, glass, which assigns a lot of physical parameters of the glass. If we have special glasses, we can create our own glass material to use it in simulations if they have special physical properties which do not match with library given ones. So this way we changed the model and now it is transparent. I expect you are familiar with zoom in, zoom out. And first thing is to activate simulation tasks is, oh, I'm sorry, I already practiced here and forgot to turn it off. So actually I was going to show you from the beginning how to activate just in case it is not activated. Just in case it is not activated, you first explore under Tools, Add-ins. All the add-ins are additional software, part of software, which I recommend students from the very beginning. In my course, we do not deal at the beginning with these, and I ask them all to uncheck these, not to load and use the computer resources when we do not need them. Therefore, now, when model is created and when we start simulation, first thing is we can explore what current version of SolidWorks, what we have, what we purchased, is available for us. Starting from 2024, academic environment has the same version of SolidWorks, the same SolidWorks premium version, the same year as industry. Before it, academic environment, we got 1 year delay. But right now, we got the same year, which is great benefit for students. So, and here is what we got for this premium version. These versions are very many. Even me, it's difficult to find out what it is. Here, there are these simulation options. And as you saw before, magnetic simulation you have to purchase. And this is not listed included in premium. I don't know how much it costs, but you can add this. So we need, in short, bottom line, we need to activate SolidWorks flow simulation to be used in our current session. After a while, it does not load immediately. After a while, it appears here. Oh, sorry. Yeah, you saw. It happens. It happens. I don't know. You had the same situation. I will relaunch. This is because I have the version which was prepared in some way which is not expected. So we don't send these reports to the not to bother. This is educational. Okay, in my case, I just need to relaunch. Sorry, it happens, but not so much with SolidWorks. SolidWorks is quite an excellent software and works quite stable when we deal with it properly. I hope you will take time and catch up with me if you didn't.
Modis, maybe
Yes.
because now we not in a classroom, in auditorium.
Yeah.
I propose to make, let's say, 20-minute break and we relocate to classroom and trying to follow
Okay.
your demonstration in computers.
Okay, so I will
no
just show
problem.
what I did before this. I turned off these two planes and assigned glass material. Assigned right click is under other non-materials, glass. I apply. I will make sure that it does not break again. Okay, and I will save. Please save. It shows that you have modified the 2017 version and save it to the current version you have. And then we can continue after your suggested break. So when we will start?
Let's say 2:40.
Okay,
And
that's good.
participants who are online, if you're
Yeah.
willing to do some practical works as well, please write in the chat and try to adjust
Okay,
control
2:40.
computer for you. Yeah,
2:40.
so we'll meet in 20 minutes time.
Thank you.